Welcome, everyone. The chat is buzzing already this evening. Let's do this. We are raising the grade boundary this evening. Seems to be the thing that we are doing. We are here. We are going to nail this revision session going into tomorrow. After what I thought was a fairly chill paper one. It was like not a huge amount of content. We got quite a fair bit we can talk about this evening. And we are going to get you raising that bar tonight. Who do we have? Who do we have in the chat? A fair few people I know. What have I got going on? Yes, Amber. Brilliant. My revision class faithful are in the house. Where is Neil? Neil is doing A-level teaching this evening. All right. So you get, is Pepsi okay, Neil, for this evening? It is moi, it is Nick. We are going to be going through all of this calculator topics. After looking through paper one, we've had a little look-see and figured out where we are going to focus our efforts. Hey, Adash, good to see you. No one's cooked. No one's cooked. We are all chill. We are all fine. So, those of you that don't know me, let's try and get the tech working. My name is Nick Featherstone. For my friends, I suppose, I am a maths teacher here at my Headspace, helping out Unc himself teach all the maths. I normally do a lot of A-level further maths, as you'll see my content on this channel and on TikTok. But here I am here to get you ready for paper 2 tomorrow. Yeah, my background really is I've been teaching for 13, probably 14 years at this point, towards the end of this academic year. Still currently in classrooms, along with my work at my Headspace. Graduated 2-1 master's degree from Oxford for my sins, kind of like maths. Did a bit of research there, so I am fairly nerdy. Are we laggy? Who have I got? Have I got a mod in the chat? My internet looks okay on my end. Hey, Adam, big up St. Mary's. That's the one. That's the one. Yes, we've got a few of you in here. Hey, Rifki. Yes, there's a few of us around. Right, what have we got here? What exam board are we working on this evening? This is catered towards EDEXCEL, but don't worry, whatever your exam board is, this is maths. There will be a few little tweaks, all right? The main difference is I've looked at what topics came up in the EDEXCEL paper 1 non-calculator paper, so that has sort of influenced what I am looking at this evening, but all the maths that we are covering this evening will be relevant, like 99% of it. All right, are we set? Are we ready? Emma, don't worry, AQA, it's all maths. GCSE maths is GCSE maths is GCSE maths. We do not worry about that. How old am I? I am of an age. A few more grey hairs than I would like, but there we go. Main thing this evening is we do not stress. We do not stress. Everything will be chill. Everything will be absolutely fine tomorrow. We are going to say this. Hey, Issa, how are we doing? Sakuna, nice to see you in the chat. Yeah. Right, let's get going. Before we go, if you've got friends who also have their exam coming up tomorrow and are feeling a little bit stressed, do just ping the link with them. This is an open stream. It's open to all right? So anyone that you feel might benefit from this, just ping them the link. They can hop on, have us on in the background and interact. It will be sweet. So Dr. Taboo, I'm not going to go over SURDS again this evening because it came up in the non-calc paper, and just to maximize our 3 hours, we're not going to cover it again. Right, now just remember, any of you who are wondering how to hop onto the chat and get some questions out there and interact with this absolutely amazing buzzing community, it's subscriber mode only, so do subscribe. Saying that right? Yep, subscribe so you can get access. That would be amazing. Turn on notifications so you can know when the next streams are coming up, and don't forget to like. It helps us out massively. Rosie, can this be EDEXCEL? Do you mean IGCSE? Fatima Hattie, yeah, again, I've taught IGCSE. There's a lot of the same content, but there are some bits that won't be in there. So for example, we won't be covering differentiation because that is not in the main GCSE, I'm afraid. All right. Lorenzo, will I be teaching some year 12 next year? I can't remember, if I'm honest with you. It's not the main point for this evening. So let's be going. We are going to start with some index rules. Now, these did not come up, but so what I'm focusing on here is not our basic index rules. I'm sort of feeling, let's see how we solve equations for our index rules. So let's get going. Let's do this. We've got 3 hours. Start the clock. Now, how do we solve these sorts of, all of these 4 equations follow a similar route. We are going to be trying to express everything as powers of A. Just before I get going again, a couple of questions about breaks. We will take a short break every hour or so we should get a couple of breaks in 3 hours is mental. I also have a cold, which is amazing. I do apologize if there's a few sneezes and so on going on. Right, so let's write all of this as powers of A. So left-hand side of this equation, we've got A, which is just A to the 1. We've got root A, which is A to the 1/2. We've got divided by cube root of A squared. Now that is A to the power of 3/2. All right, full on, if we go look at rule number 8, that will give us that one. Rule number 8 over here is equal to A to the X. Now, can we, 3/2, 2/3, there we go. First typo of the evening. Let's go. 2/3. Right, now, rules of indices. What do we get on the left-hand side as we simplify that? Yes, chat, you caught me on the 2/3 already. Little blip as we start out. Now, our rules of indices, we are going to, that is A to the power of, we got A to the 1. We're multiplying by A to the 1/2, so we're going to have to add a 1/2. And we're dividing by A to the 2/3, so we can take away the 2/3. All right. Joseph, do we need to remember the rules? Yes, you really do need to know these rules. Now, beautifully, we can either work with the fractions, or if we are of a mindset, we can just bring out the calculator. I'm afraid that I am a big CG50 sort of a person, so we are going to go with this. Let's just get all the further maths out the way. So 1 plus 1/2 minus 2/3, which is 5/6. All right, let's embrace the fact that tomorrow is a calculator paper and go from here, which should tell me that X is 5/6. Why can I do that? Because the bases are the same. All right, because these are both A to some power, which tells me that the powers have to be the same. All right. So where are the fractions from? I invite you to go refresh your memory on the rules number 7 and 8 over on the right hand side are expressions for the rules of indices. I recommend you go have a little let's. All right. So that is our first cheeky answer. Is this useful if we have OCR non-calc? Yes, Anna, you could do all of these questions on this page with the without a calculator as well. Obviously, some of these questions as they come later on will rely on the calculator, but there's a lot that are non-calc as well. So do not worry about it. Let's go. How many have we got? We have 1,100 people on the stream at the moment. Do send that link out, guys. Let's see how many we can get on. See how many subscribers we can get me to by the end of this evening. Asblash, how did I get 5/6? That is 1 plus 1/2 minus 2/3. You can either find a common denominator or take advantage of the fact that for the main GCSE we have a calculator paper tomorrow, and as much as it breaks my heart, we can do that on the calculator. Yeah, you can use any calculator tomorrow. Right, B. Let's have a look. We need to deal with that left-hand side and write it just as a nice power of X. So what have we got? Let's do this one in steps. Let's add in a few more steps. We've got cube root of 1 over x to the power of 4 is equal to x to the m. Now, I am going to go one step in already. 1 over x, go check out rule number 5. That is x to the minus 1. cube root, that is the power of a third, power of 4. And now we can use rule number 3, power of a power of a power. X to the minus 1 to the power of a third. You multiply those two to get x to the power of minus a third. So what is my value for M chat? Let's get some chat interaction going. What have we got? Let's pop it in there. Amar, there will be further maths A-level available next year. Yes, let's go. Minus 4/3. Wicked. Okay, so all we are doing in all of these questions where we have to solve these equations with horrible surds and indices, the goal is always to express everything as some powers of something, right? Always as powers of something. And the same something. We want that same base. We want that same old base. Here, everything was base X, everything was base A, and that is our goal. Right. Let's have a go at C. These are definitely the harder end of the indice questions. All right. These are definitely the harder end of the GCSE questions. Sam Locke, why the minus a third? Because we picked up an x to the minus 1 because it was 1 over x in there originally. All right. 1 over x is x to the power of minus 1. All right. That is where that comes from. Guys, these can come up in the exams. I've based these on exam questions I've seen in papers. Is this above a grade 6? Yes, this is defo. I would expect these to be sort of middle back end of the paper. But they are worth exploring, right? You can get some easy marks in there just by plodding through them and starting to write a few different powers. Right. Now, let's look at C. We've got a left-hand side and a right-hand side. We are starting big this evening, boys and girls. There will be some slightly more chill questions, all right? But we are aiming high tonight. All right, first thing I want in the chat is left-hand side. Can you simplify that power on the left-hand side? So how many marks on each paper for 7? Oh, somewhere around 55 to 60%, I think it is for grade 7. So left-hand side, power of a power, that is a half times n, which is n over 2. Wicked. Right-hand side. Now, here's the thing, gang. Even if you aren't so keen on doing the entirety of these questions, you do need to be able to use, even if you are gunning for grade 5 or grade 6, whatever it is, you need to be able to be comfortable using these rules. So don't focus on the entire question necessarily. Focus on the small steps. In part A, make sure you are happy with y root, that root A is a to the half. Cube root of a squared is a to the 2/3. For C, look at the small individual parts. Right. The denominator on the right-hand side. Now, everything else is powers of 2. Everything else is powers of 2. So what we'd quite like is instead of 8, we would like powers of 2. So what is 8 as a power of 2? I think I might have seen that knocking about. What is 8 as a power of 2? Laura, for 7, it's about 55, something like that. 55, 60, depends on the year. Oh, cube coming in strong. Yes, 8 is, oh, he says as he writes a 3. Hand working faster than brain, or the other way around. So 8 is 2 cubed. All right, so all I've done here is instead of an 8, we've written 2 cubed. So nice little step that we have there. Right, now our goal is to simplify this. So we have 2 to the x divided by 2 to the 3y. We can use our rules of indices. I invite you to look at rule number 2. We are at rule number 2 to get from here to here. If you are dividing, and again now we are pretty much home free because we've got the same base, the same number at the bottom. That is 2 to the x, take away 3y. Awesome. And now, because we have that same base, I can say that n over 2 is x minus 3y, which means we can now get a expression for n. Let's go. What is my expression for n? Rosie, no, this is not a question at the start of the exam, right? Do not think I've not tried to reproduce an exam paper this evening. I've taken topics that have not come up, and I've tried to put together a collection of interesting questions on them that will challenge us a little bit, whilst also letting us practice the basics as well. So, what have I got? I've got some great stuff coming through in the chat. Well done, crew. We have got this. Multiply both sides by 2. Look at you go. That is 2x minus 6y. Again, if you're feeling lost with the entirety of the question, these are difficult. These are tricky. We've got some nicer ones coming up. Do not worry. All right. But look at the individual steps that we've taken. Okay. Now, last one. Let's go. 16 to the 1/5 times 2 to the x is equal to 8 to the 3/4. All right. So, if you are struggling with my handwriting, do let me know. That is a 1/2 up there at the start of C. So our goal in D is to get the same base. All right. So 16, for example, and we're going to take the smallest base we've got between them. So I've got a 16, a 2, and an 8. So the smallest one there is a 2. So we are going to write everything as powers of 2. 16 is 2 to the power of 4 times 2 to the x. 8 is 2 cubed. Let's get some t in there. All right, now we are going to be using rule number 3 a couple of times here. Power of a power. We have to multiply them. 4 times 1/5 is 4/5. And 3 times 3/4 is 2 to the 9/4. Julia, don't worry too much about the overall process necessarily. Have a look here at these rules here where I've going in purple. Are you happy with what I've done on those purple arrows? All right. Focus on the smaller parts that we can control. Now, we are multiplying. We now have the same base, multiple places, 2, 2, 2. Which means I can use rule number 1. That is 2 to the 4/5 plus x is 2 to the 9/4. Skater, you can go to the bathroom at break. Do we have to put it in decimals? Let's discuss that. Now, because I've got the same base, now what are we looking for? Let's take a second to look at our command words in our papers. It says here, exact value. All right, it says exact value. Now that means we want to go for fractions, surds, whatever it is. All right. So what is the calculation I have to do now to get x? What do I have to do to get x? No, Sujal, like I said, this is not necessarily an order at all for the paper at all. We are going to do, well done, chat, well done, excellent, 9/4 minus 4/5. And let's be a little bit lazy. Please don't think this is what I do in real life, but I know so many students do these things just to check. Just to check, sir. What was it I found someone doing yesterday? 3 times 4 on the calculator. Absolutely mental. Right, what have we got here? Sumaya, why is it minus when it's multiplied? It isn't. It isn't. In part C, there's a minus because they are being divided. And we haven't picked up any minuses until right at the end in part D. Part E, we would put this as a fraction because it's asking for exact value. Much better as a fraction. So for B, you can make all the bases as 16 if you want. Why would you do that to yourself? Oh dear, why would you? It's much, much easier going for the smallest base. All right. Now, again, these I've gunned in. I thought we'd go in strong. We'll go in strong, but look at the smaller parts of it. Are you using the rules? Were you able to use the rules correctly on the left-hand side? Hopefully, there weren't any of those little 1 mark, 2 mark questions in paper 1, so hopefully we'll get 1 or 2 of them. But hope the best, plan for the worst. Let's make sure we've gone through a few of these. If they do come up later in the question, at least we can attempt them and get going on them. Rosie, this is a nut-free stream. Please be considerate. Okay, let's go. So that's really where I wanted to go with the index rules, those really tough ones, but make sure you can do all the individual bits going. Right, we have got 5 or 6 slides of quadratic, so let's go full quadratic. Looking at this, we've got a right angle triangle. It tells me it, so let's put the little right angle in. What am I going to be using, chat? What theorem am I going to be using? I see a right angle triangle. What is my brain telling me straight away? Ayush Ramani, for index rules, that is the hardest it's going to go. Right, let's get some Pythag going, gang. Let's get some Pythag. We've identified this absolutely fine. So what have we got? We got x plus 1 squared plus x plus 3 squared is x plus 5 squared. All right. Here we go. Now we just have to expand this. X plus 1 squared, x squared, 2x plus 1 plus x squared plus 6x plus 9 equals x squared plus 10x plus 25. Now, obviously, I have limited board space. I've been doing this a long time. I expand fairly quickly with minor mistakes for the most part. So if you need more space to do this, take the time, take the space to expand these and make sure you are picking up especially these middle terms, all right? Do not, in the rush of the moment, let yourself not expand properly. Are the amounts of marks for each question accurate? To the best of my ability. I've based these on past exam questions. And I've gone for the amount of marks. So this is an exemplar. Now that can change from year to year, +1, -1 mark, depending on how what the vibe is of the examiner and where it is in the paper. But this gives you a good idea. Right. Let's tidy this up. So left-hand side, I've got 2x squares. I've got an 8x. I've got a +10. Right hand side, I've got an x squared, I've got a 10x, and I've got a +25. Let's tidy that up. Let's minus x squared. Let's minus 10x. And let's minus 25. We took away an x squared from both sides. We took a 10x away from both sides. And we took away a 25 from both sides. That is a 25. My handwriting can be a little cramped. So that is part 1 done. Show that. This is our answer. Whenever it's show that, this is what my final line of working needs to be and not before. That is very important that we get our command words properly. Show that. So whatever comes after the show that is our final line of working and not before. Now, does this factorize? Yeah, possibly. This one does factorize, in fact. So giving your form, your answer in the form a plus or minus b root c. When I put these together, I may have accidentally made it factorize, but that's all cool. X minus 5, x plus 3 is 0, or we could just use our quadratic formula. Let's say we didn't see it. X is minus b plus or minus square root of b squared minus 4ac over 2. So that is 2 plus or minus square root of 64 over 2. Now, it does just so happen for us that root 64 is 8, which is awesome. So that is 4 or even 5 or minus 3. All right. So we can go with this. Sophie B, is the quad formula on the equation sheet? Do you know what? I haven't looked at the GCSE. I mean, there isn't really a GCSE formula sheet. It's just a few formulae slapped on the back of the front page. I think it is, but you really should know it. You really should know it. And even it should be here properly. How did that happen? Plus BX plus C. All right. Awesome. Sonia, you don't have to. Like, this is a perfectly reasonable. All right, now. This one somehow I managed to make it come out fine without really meaning to. This is just going to be B equals C equals 0. So this is absolutely fine. All right, so I wouldn't worry about that too much. All right. Let's use the quadratic formula over here. That's going to annoy me all day. Let's go on to the next one. Felak, how do you know I have to use Pythagoras for part A? Because you are given a right angle triangle. That is your massive, massive hint for that one. Yes, Musab. So if you don't want to factorize, this is a calculator paper, so just use the quadratic formula. Unless the question specifically tells you to factorize, you are good to solve it however you want. Okay. So the form here, Swiss Rex, is pretty much this. All right, you could write it this way. If you really, really wanted to, you could write it as 1 plus or minus 1/2 square root of 64. All right. If you really wanted to do that by splitting the fraction up, you could absolutely write it in that way. Okay. Right. Let's get on to this. I've already got some algebraic fractions in here. All right, we've got some algebraic fractions. So here we will go through vectors later on this evening. I've got a bunch of vector stuff lined up for us, but we need to crack on with some of these slides, so let's go. So we are going to create a common denominator. So first thing we look for is to see if either of these denominators factorize. 3x minus 1 does not factorize. X squared plus 2 does not factorize. So my common denominator is going to be, going to make a little bit of room here. My common denominator is going to be 3x minus 1 times x squared plus 2, which means I need to multiply the top here by x squared plus 2. And on the right-hand side, we also get that same idea. All right. So we've now got, Zara, we're going to avoid cross-multiplying. We're not a big fan of cross-multiplying here at my EdSpace. Now on both sides, I can multiply by the denominator. We can multiply both sides by the denominator, which effectively cancels them out. And now it's expansion time. So can you pop in the chat for me what the quadratic is going to be? What is the quadratic I'm actually solving, please, chat? Can you tell me what that is? Sakuna getting in there. Sadia, I think you've got it the other way around. Cross multiplying is what I've done. It is not that what I have done is cross multiplying. Cross multiplying is the shortcut for what I have done, but there are circumstances where it is a little bit iffy. All right, so this is the proper full way to do it. Right, what have I got? I've got some stuff coming in here. Excellent. We've got 4x squared plus 8 is equal to 6x squared minus 2x. And if I simplify that, I get 2x squared minus 2x minus 8, which is x squared minus x minus 4. All right. So from here to here, we divided by 2. We now need our numbers. So we are going to use the quadratic formula. So let's identify a, b, and c. In this case, it does not factorize. So my quadratic a is 1. B is the coefficient of x, so b is minus 1. And then finally, boop, we're going to find our c, which is there. We get c is minus 4. So x is minus b, minus minus 1, plus or minus square root of b squared minus 4 times 1 times minus 4, which is 1 plus or minus square root of 17 over 2, which is all right. So you are right, I didn't need to do the step here technically to divide by 2, but it's a good habit to have if you see that a bunch of these have common factors and we can simplify it. I like to. It can make the numbers easier to work with in the calculator, but it's 1 plus or minus root 17 over 2. So let's go. 1 plus root 17 over 2 would give me, thank you calculator, that's most useful, 2.56 as one option, or the minus option. Oh, all right, 1 minus root 17 over 2, thank you calculator, most useful, minus 1.56. Okay. So what else we got? Where did the denominator go? I multiplied through by it, Lena. All right. I multiplied both sides. That's what I've done in purple. Do you need to show working with the quadratic formula? This line here, where you actually show what you've plugged into your calculator, that is your working. So on a calculator paper, here's my general tip for that to make sure you get your method marks. If you've plugged it into the calculator, you should be writing it down. All right, if it's in the calculator, it is written down. That is a good, just general rule of thumb of where we want to be on that one. Okay? Brahampreet, I know, but this is what I have on this PC, so we are using my graphical calculator. Okay, so the best way to show you're working when using the calculator on the calculator paper, no matter what the paper, what the exam board, what the calculator, is to just write down what it is you've plugged into the calculator. It is that simple. All right. Do you need to show working? No, we've got that. Why don't you write minus 1? Do I need a minus 1? Why would I need a minus 1? So b, I see. B is minus 1. And remember, in the quadratic formula, it's minus b. So this is technically, that is minus 1 is what that is. That is minus 1. All right, is minus 1, which is plus 1. All right. So, Swiss Rex, can we leave the previous question with the form? The form that was written was assuming that the question did not come out with integer numbers. It did come out with integer numbers. We're just going to leave it and move on. The key thing to get out of it was how to form the quadratic in the first part. All right. You will not get a question that does that for you, I promise you. All right, that is my numbers went a little bit skewy on there. I made it work a little bit too nicely. You will not get a question where you can't just write it down obviously in that form. Right, now, x squared to 3x plus 2 is the same as the ratio 1 to 3. Little key thing here, we've got some early work on ratios as well. What that means is, what I can do is I can compare both sides. Because what it means is that x squared over 1 is the same as 3x plus 2 over 3. Okay? So that's what we've got. That's how we are going to, go from that ratio part to something that we can turn into a quadratic. Okay, so we are now going to get rid of our fractions because the fractions are horrible. So I'm going to multiply both sides by 3. Wow, I just did a backwards 3. That is just like... So that will give me 3x squared is 3x plus 2. So Ellie, Tiki, you could do it that way. But so you can either do dividing both sides of the same ratio, or you can divide the equivalent sides of the two ratios. It doesn't matter. It comes in the same. The reason I've done it this way was to avoid algebra in the denominator because I didn't feel like it. You will get the exact same answer. Right. Oh, plus 2. That's a minus 2. We now need to reorganize this. All right, so we take away 3x from both sides. We take away 2 from both sides. And this is the quadratic we end up. We get a is 3, b is minus 3, c is minus 2. So we're going to have to... Why is it minus 2, Lara? Because we had a plus 2 on the right-hand side. We want to move everything onto one single side of our equation. So we're trying to make the right-hand side 0, basically. So to get rid of a plus 2, we have to subtract 2. Right, this is our quadratic. We've got a is 3, b is minus 3, c is minus 2. So now we can plug that into our quadratic. So minus b, now again, same as before, b is negative 3. So minus 3 is plus 3. Plus or minus square root of b squared is 9 minus 4 times 3 times minus 2 over 2a, which is 6. So that is 3 plus or minus square root of 4 times 3 times minus 2 is minus 24. 9 minus minus 24 is 33, I do believe, over 6. And we can get our numericals, which is going to be 3 plus square root 33 over 6. What do you get? 1.45? 3 sig fig, so 1.46. Or, let's see if I can not erase my own working this time. Minus 0.457. Making sure we are putting in the correct number of significant figures. Head elf, you can always use the quadratic formula with a negative a as well. That works absolutely fine. If you wanted to do that, you are absolutely good to go. All right. If you made Malika, you can make whichever side you want 0. It depends what makes whatever makes the most sense for the question. Really, it's up to you. Okay, so really, main thing to concentrate on here, we've done a little bit of algebraic work, but in terms of the quadratic formula, make sure you're identifying your A, your B, and your C correctly, and you are looking out for negative signs, especially for the calculator. Where did I get the 9 from? That is 3 squared. Well, it's minus 3 all squared. That 9 here, that is minus 3 all squared. And do make sure, other tip for the calculator paper, is that you use your brackets properly. B squared, if B is minus 3, you're doing minus 3 squared. That is not the same as minus 3 squared. Those are two different things. All right. Okay, let's go. Floof, you should not get a negative inside the square root in a question that is designed to work. All right, in a question that's trying to show that there are no solutions, but that's more of an A-level thing. That's more of an A-level thing. But you should not get that. If you do get a negative inside the square root, go check your brackets, go check your signs. Chances are you've done something like what I've just highlighted here. You didn't put brackets around a negative number or something like that. Okay? B is minus 3. Khalid, B is minus 3. Again, we've got minus B, which gives us the plus 3. Riley, how many decimal places? If the question doesn't tell you, and it should, we go for 3 significant figures. All right. Okay. Right. Let's talk quadratic sequences. Let's talk quadratic sequences, everyone. Now, this is also linked to quadratics. We're going to be using quadratic expressions. That's why I've popped that in here. Let's go. So what is a quadratic sequence? We've got 3, 5, 9, 15, 23. How do we get from 3 to 5? That's a plus 2. From 5 to 9, that's a plus 4. From 9 to 15, that's a plus 6. From 15 to 23, that is a plus 8, which means the next sequence, we're going to go for a cheeky plus 10. This is what a quadratic sequence does. What you increase by increases. So in this case, the amount I'm going up by goes up by 2 every time. So we should get 33 and then 45. Okay. Now, if you get a question like this, you will be so happy. 2n squared plus 4n minus 1. You want the 12th sequence term. What is the 12th term of the sequence? Let's go. And yes, Ibrahim, I've got some completing the square coming up. Got 335 in there. Let's find out. We're going to plug in n is 12. So that is 2 times 144 plus 48 minus 1. That's 288 plus 48 minus 1. What's that? 320, 336, 335. Again, calculator paper, feel free to use the calculator. These are super light. They're just easing us back into what a quadratic sequence does, how to use the formula for a sequence. All right. We can use our calculator for it, and we can crack on with there. Ray, you just need to make sure it's in degrees. You just need to make sure it's in degrees, which is in your mode part of it. In the setup, sorry, in the setup part. But that will depend on calculator to calculator. All right. So, Gab, there was a completing square on paper 1, but that's why we're going to go for the slightly harder one. But let's crack on with quadratic sequences. So let's get a formula for the nth term of this quadratic sequence. Now, do I know that it's a quadratic sequence? Yes, because that goes up by 2, that goes up by 4, that goes up by 6, that goes up by 8. All right. So this tells me this is a quadratic sequence. This tells me this is a quadratic sequence. Now, generally, we're going to, one of the nicer ways to do this is actually, a quadratic looks like this, an squared plus bn plus c. Same as the quadratic formula we've been using, just instead of x's, I've got n's. And what we're going to do, a nice way to do this is, well, let's create some equations. So what do I get if n is 1? Well, I would get a times 1 plus b times 1 plus c. And what is the first term? It is 1. I'm also going to look at n is 2. What would happen to this formula if n was 2? That would give me 4a plus 2b plus c. And what is that equal to? That would have to equal to 3. And I'm going to do this one more time. N is 3. That would give me 9a plus 3b plus c, and that would have to equal to 7. All right. So this is slightly different to another way, other ways by looking at the second difference, but I quite like this one. It's a little bit neat. It's a little bit different. And then we are doing simultaneous equations, essentially. So if I call these equations 1, 2, 3, if I do equation 2, take away equation 1, that is 4a plus 2b plus c is equal to 3, and a plus b plus c is equal to 1. If I subtract these, I get 4a take away a is 3a, 2b take away b is b, 3 take away 1 is 2. I'm also going to do equation 3 take away equation 2. So that is 9a plus 3b plus c is equal to 7. 4a plus 2b plus c is equal to 3. And we are also reviewing our simultaneous equations for all of this. 5a plus b is equal to 4. And now, these are quite nice and chill simultaneous equations to solve. We've got 5a plus b is equal to 4. I've got 3a plus b is equal to 2. And again, if I subtract these, I'll get 2a is equal to 2, which tells me that a is 1. And I can start plugging all of this back in. If I know a is 1, I don't know, I can plug that back into there and get 3 plus b is 2, which tells me that b is negative 1, and plug everything back into equation 1, which it was a plus b plus c is 1. So a is 1, b is minus 1, plus c is 1. So I think c should come out as 1. All right. So that tells me that the formula for my nth term is with a is 1, b is minus 1, and c is 1. That is my nth term formula. So 5 minus 2, yes. 9, 6, 7, yes. Yes, that works. Happy with that. Lovely. Okay. Do whichever method you find best, all right? But if you've got to this point the night before and you really don't like quadratic sequences, here's a different method. Here is a different method to try, okay? it's quite nice. You can crack on with it. Otherwise, what time is it? 6:21. We can have a quick go. 1, 3, 7, 13, 21. You can look at the second difference. The second difference is plus 2. All right, our second difference is plus 2. And I divide that by 2, which is 1, which tells me that the coefficient of n squared is 1. So I've got n squared. I'm then going to write out the sequence n squared, which is 1, 4, 9, 16, 25. And I'm going to subtract them. I'm going to see what's left. I know that n squared is part of my sequence. And let's see what's left. I've got 0, minus 1, minus 2, minus 3, minus 4. This sequence here is linear. All right, so it follows the same linear patterns that we're used to. And you'll see here we've got a constant difference. We are subtracting 1 every time, which tells me that's minus n. I need the first term to work, which means I need to add 1. So altogether, my sequence is n squared minus n plus 1. So that is the other method you could go for. So Alex, if your calculator will do polynomial straight up, yes, you do need to write out your working. Hey, Sadia, I'm happy people doing whatever. I just like to show different methods, especially when we're coming to some last minute revision, right? Give you a different approach, a different view. It's not a bad thing ever at all. And Riley, it does not matter which one you do, whichever you are most comfortable with. If you've got a method that works for finding this, you crack on and you just do it. All right, but here I've given you 2 points of view, one very, very algebraic, the other one much more about understanding the ins and outs of a sequence. Really, horses for courses is up for you. All right, but this bad boy here, I love me a little bit of algebra. And yeah, A boy, the nth term here, once you've got the linear one, it's super quick and easy. But if it's a horrible value of A, it can be a little bit worse. So Lara, if you remember all of those, you can, but I try to avoid giving a whole bunch of formulae to remember, if I'm honest with you. But yes, Lara, what you've just said there comes from all of the gubbins I did in the first method. I don't like having to remember a whole bunch of formulae, but that's just personal. Okay? Right, let's go. Let's do the next one. Let's talk sketching quadratics, which funnily enough has some completing the square. Now in paper 1, there was some completing the square, but not with a number in front of the x squared. So that is what we're going to focus on. How do I complete the square with a number in front of the squared? So we've got 3x squared minus 6x plus 5 in this form. Let's go. First thing we do, we take the 3 out front. Now, I'm going to use big square brackets, and I'm only going to factorize the 3 out from the x terms, right? Look at that. I didn't want to take a 3 out of the 5. I don't want to deal with fractions right now. So I'm only going to take the 3 out from the x terms. And you know what? I'm even gonna go for this. Right, now, on those blue terms, we just complete the square like we do normally. So x squared minus 2x, we've got minus 2x, which means we need to half that to get minus 1. And then we're going to take away 1 squared, or minus 1 squared rather. Okay, so that is 3 times x minus 1 squared minus 1 plus 5. And now we are going to expand these brackets out, which is 3 times x minus 1 squared minus 3 plus 5, which we can tidy up over here. Okay. Some great answers coming in the chat. Keep going, everyone. Keep going. Help each other out. Where did the 2x come from? The 2x is from here, when I factorized out the 3. All right. Hence or otherwise, write down the coordinates of the turning points. This is part 1, part 2, part 3. Now, the turning point, we've now got, the turning point comes from these numbers. So this tells me that the turning point is at 1, 2. Remember, if you've got this written as ax plus b squared plus c, the turning point is at minus bc. All right? Ayush, you would get the same answer if you went through all of this with 5/3, but if I can avoid doing the fractions, I will avoid doing the fractions. So that's why I do it this way round. Okay? And again, when you're plugging this in, if you're using your calculator for whatever reason, don't forget to put brackets around the -1. Okay? Now, let's sketch this. So give ourselves a little graph. Now, our turning point is at 1, 2. That's our turning point. We're also going to put in our y-intercept. Our y-intercept is going to be at +5. How do I know it's at +5? Let's choose a different color. How do I know it's at +5? Because of the original quadratic. And now you have the joy of watching me try and sketch on this writing tablet, which is just going to be horrific. That's not terrible, actually. That's not terrible. So, Ray, how did I realize it has no roots? I didn't think about it. It told me just to complete the square, so I completed the square. It told me to complete the square, so I completed the square, and that's it. It told me to. All right? So we don't have to worry about that. All right, one more, and then we'll take a cheeky break. Oh, look at that limitness. It's almost as if... All right, one last question for Erin. So how is it -1 squared? What color have I not used here? Let's go for pink. That -1 squared there is because of that -1 there. It's all designed so that if I was to expand that blue gubbins in the red bracket out, if I was to expand all of it and tidy it up, I would end up with x squared minus 2x. Them's the rules. Okay. How do I get -3? The -3 is 3 times -1 when you expand that. When you expand our square brackets, that's where that's coming from. All right, let's do one last quadratic-y thing. Excellent. Let's go for that one. Same idea, even with a minus. So I would suggest that first, I'm going to rewrite this in the order that I want. So x squared first. And then we do the same thing. We are going to factorize out the number in front of the x squared. So that is a minus. And I'm also going to leave the +4 alone out here. So that is an x squared plus 6x And there we go, because we've taken out a -1. Now we look at the number of the x's. It's 6. We're going to half it. Oh. We're going to halve it to get x plus 3 squared. Now let's go through the logic for this again. The reason is, if I was to expand this, I would get an x squared. Epic, that's what I want. I would get a 6x. Excellent, it's what I want. I would also get a +9, or that makes me sad. I don't want a +9. There is no +9 in my square bracket. So we have to take it away. Okay. We're then going to expand this back out to get minus x plus 3 squared plus 9 plus 4, which is minus x plus 3 squared plus 13. So, boy, no, there is no equation here to equate to 0, so we cannot swap the sides over and swap the signs. This is not an equation, it's an expression, so you can't do anything that would change fundamentally what it is. So I cannot multiply everything by -1 or anything like that. So that is part 1, part 2, part 3. Right, hence or otherwise, write down the coordinates for the turning point. We've now got this written in the way that we want. Our turning point is at -3, 13. Nice and simples. And then finally, let's draw this graph. Let's get some axes out. And let's get to drawing. So our turning point is at -3, 13. So, I don't know, somewhere up here. Our y-intercept is at +4. Again, y-intercept at... Silly boy. Nope, that is the wrong color for that. +4, +4, +4. That's where that comes from. And it is an upside down parabola. Oh, that is shocking. But you have access to paper, which would make it much, much nicer. Going through the turning point, going through my y-intercept. All right. It's not asking me to find the roots. It's not asking me to anything else. It's just sketching it. And something like this, when you've done the turning point, the main bits to put on are the y-intercept, the turning point, and you are solid after there. Why is it an upside down U? Because I have a negative x squared. What makes it upside down is the negative x squared. That's what's doing that for me. All right, the upside down U is coming from the negative x squared. That's what's making it upside down U. The minus has affected the -9 when I opened up that square bracket, so that sorted that one out for me. Why does it go to -3? That is a much deeper issue for today. What I recommend really is just, having said that I don't like learning stuff off by heart, really, we don't have time this evening to go into the whys of everything. Just remember, if it's ax plus b squared plus c, your turning point will be at -b and c, and we will leave it at that for right now. All right. Okay, that is a solid hour's work, everyone. Let's take a 5-minute breather. Let's take a 5-minute breather. We'll be back at 6:40. Let's go 6:41 by the time we log off. I am going to disappear for a couple of minutes as well. It's the little one's bedtime. grab a quick snack, refill your teas, refill your coffees, refill your waters, so we can get going for the next set. All right, so 5-minute break, everyone. 5 minutes, and let's go. How are we doing, cool kids? We still here? We still ready to keep going? How are we going? We got a little break. We got our tea. I've got myself a nice fresh mug of tea to keep us going. And we will keep working on towards the much harder parts of this paper. So let's get some more questions in. Felix, how did I change the -6 to a +6? Now, because I factorized out a -1, because there was a -1 in front of the x squared, I wanted to pull that out in front of my big square brackets. That means I had to pull out a -1 from the 6x and the -6x as well. So there we go. Okay, that's why we are doing that. So let's crack on. We've got some circle theorems coming this evening. We've got some vectors coming in this evening. We've got some 3D Pythagoras coming in this evening. We've got all of that ready to rock and roll and help you out. Do not forget to subscribe if you haven't already, so you can pop some messages in the chat. Let's get everyone back in from our break, and we will get going again. Do not forget that we have Cram courses for these other GCSE subjects as well. I think a load of you already said you've been doing English with Alex and Louis over there. We've got physics with Brooke does physics. We've got chemistry with LaJoy does chemistry, and biology with Laura does biology, all running Cram courses. It's not too late to sign up, and they are all completely free. So do check out the links in the description as well so that you can sign up for those. We will finish when we finish. Why did I make the 9 a positive, Max? Because again, when I multiplied out my square bracket, I had a minus in front of the square bracket. So it applies to the x plus 3 squared, and it applies to the -9. So it's a -9. Right, let's move on. We should pick up some pace, but there we go. Okay, we've got a line is y equals 2x minus 1. We told that L2 is perpendicular, goes through that point. L1 and L2 intersect at point A, and so on and so forth. So if we're doing some geometry, handy tip, let's draw some axes and see what goes on. Right. So 2x minus 1. Let's go with that. Okay. Now we want a line that's perpendicular and goes through the point -8, 11, something like this. Okay. So what is my perpendicular gradient? If the line L1 has is equation 2x minus 1, what is my perpendicular gradient, chat? Let's pop that in there. Yes, for our negative reciprocal. Let's go. So if the gradient was 2, my negative reciprocal is -1 over that 2. So it is -1/2. So the gradient of our perpendicular line, L2, will be y equals -1/2x plus c. How do I find that plus c? Let's pop in our point. Let's pop in the point. So y is 11. Boop. And we need to play around with this a little bit. Let's tidy that up. Minus 4x. Ridiculous. Plus c. So I get c is 15. So the equation of L2 is -1/2x plus 15. We are here for the good stuff today. We are here for the good stuff. Might need to change this around just a little bit for me. That can't be right. What have I done wrong here? What have I done wrong? Oh, it's -8. Thank you, chat. I could tell that was going wrong. I could tell that was going wrong. C is 7. Thank you. because my picture was impossible. This is where drawing a picture can save your bacon, boys and girls. Drawing a picture can absolutely save your lives. All right? No matter how many degrees you have, how long you've been doing it, draw a picture. It can absolutely save you. Right. So this is now L2. This is now L1. Nick needs sleep. Nick is a little bit tired, but that will not stop us. Nick mostly has a cold, I think, is the bigger problem. Right, line L1 intersects the x-axis at point B. So this will be point B here. L2 intersects the x-axis at point C there. And they intersect at point A. All right, they intersect at point A. So what we really want to do is figure out where... Is this going to work? Is this going to allow me to do this? Nope. Was this overly ambitious? A bit of screenshotting mid, maybe. So what we need to do is figure out the area of this triangle ABC. So we would quite like to figure out what some of these coordinates are. All right, so coordinate of B. We're going to take y is equal to 2x minus 1. What's the coordinate of B, chat? What is the coordinate of B? So we're going to solve with y is 0. What do we have? Minus a half, plus a half, plus a half. So that is where B is. I've started with B. I've started with B. You're starting with other bits and bobs. We can do A as well. We need to find where these two lines intersect. Okay, this is a 6 marker. There is a fair amount going on. So simultaneous equations. 2x minus 1 is minus a half x plus 7. Now, I don't really want... You'll quickly notice I try and get rid of fractions as soon as I can. So I'm going to multiply both sides by 2, which will give me 4x take away 2 is minus x plus 14. If you are not fractions fans, especially with algebra, just get rid of them. Multiply everything through. I can then add x to both sides. And I can add 2 to both sides. This gives me 5x is equal to 16, which is x is, I don't know, 3.2. We do want the y value, so y is, plug it into one of these two, plug it into 2x minus 1. 2 times 3.2 take away 1, which is 5.4. And I've sort of run out of space here. I'm in the way. Let's move some things around. Much better. And we still need to find point C. So we will plug in 0 is minus a half x plus 7. That tells me that half x is equal to 7, which tells me that x is equal to 14. So that is at 14. Where do we say B was? B was at a half. This is very obviously not to scale. But the key is to now find the area of this triangle. Well, what's the length of the base? We are going from a half, or 0.5, if you'd rather, to 14. That length from 0.5 to 14 is 13.5. And the height is just the y coordinate of point A, which is 5.4. So the area is 1/2 base. Oh, we're going to run out of room again. Times height, which is, and do you know what? Let's get the calculator out. 1/2 base times height. 36.45. Ali, why did I use simultaneous equations? That was to find the coordinate of A, i.e. where the two lines meet. This sort of thing is actually quite frequent. Sorry, I'm fighting off the cold here. These things are quite frequent. Exam boards love these sort of questions where you've got the two lines, you've got to make sure they meet, and then you can find areas. All right, sometimes it's this little triangle here. Sometimes it's the triangle up here on the side. They quite like that one as well. These are quite frequent questions. Ollie, how did I get 13.5? It's the distance from B to C. That's all it is. All right. The marks themselves. All right. So we are going to have to speed up if we want any chance of finishing somewhere near 8:30, boys and girls. The marks. So you would probably get a mark for figuring out the reciprocal gradient. You would get a mark for figuring out the equation of the line. Then I would expect a mark for finding the x coordinates of B and C, a mark in there, a mark for finding that y coordinate, and then a mark for finding the area. Something along those lines. That does change a little bit. All right. Jess, we can't use -811 because -811 is just a random point on L2. It's not where the two lines meet. It doesn't tell me that. It just says that L2 goes through that point. It doesn't tell me that's where the two lines meet. Okay, I'm not sure what equating the coefficients means, nor Lambert. Okay, let's do a quick rhombus. A, B, C, D. We know the coordinates of A are -2, 10. The equation of the diagonal DB, let's see if I can draw DB in. So the equation of that diagonal is y equals to 2x plus 4. Form an equation for AC. Now we are going to use a fact. What is the fact that we are using about the diagonals of a rhombus? What do we know about the diagonals of a rhombus, chat? They are perpendicular. All right, they are perpendicular. Brilliant. Okay, so if I want the equation of the diagonal AC, all I need is to know that its gradient, again, this had a gradient of 2, so the perpendicular gradient becomes -1/2. And then we can just go into y equals mx plus c and make it go through -210. What's my answer, gang? Let's go. Nice quick one, this one. This is a -210. My handwriting got a little bit sloppy over there. What do we got? -1/2x plus 9. Give me a check, chat. So x is -2 plus c. Cool. Sorry about that. Had to blow my nose. Not easy to do discreetly on stream. Right, so the equation of AC is y is minus a half x plus 9. This is a real, in terms of the actual equation of the line, this is bread and butter, nice and easy, easy peasy, squeeze the lemon for 4 marks. The real thing you needed to know here is that the diagonals of a rhombus are perpendicular. Do I need to work out the y-intercept every time? Well, some questions don't worry about it too much. This one very much does, because we want the full equation, so we do need it. Okay. Now, all of that leads us into circle geometry. So what have we got? We've got a couple of classics coming out here in terms of what we need to do, but this is a 5 marker. There's a few bits going on. We've got the circle x squared plus y squared equals 20. So let's draw a circle. I'm going to put some... There we go. Cool. Right. Line L is tangent at the point P with x coordinate 2. Well, okay then. That is the point P. We want to find the tangent at that point. Okie dokie, we can do that. Give or take. That looks good enough to me. So we need to find the equation of that tangent. Now, the first thing we want is the y-coordinate of P, because we are missing that. So let's find the y-coordinate of P. So we're going to put in x is 2. What is the y-coordinate of P? Let me know, chatteroo. Let's go. So we get x is 2, so 2 squared plus y squared equals 20. Yeah, we got some coming in here. Y squared is 16, so y is 4. So we already know that that is at y is 4. Lovely. The key part to any equation that has to do with a circle... Oh, I thought for some reason that was a line. That has to do with tangents is the fact that, and I saw someone pop that in the chat, is that the radius and the tangent are perpendicular. Okay, again, this is a cram session. We cannot reteach everything from scratch. So Sophie, we do need the gradient of the radius, but to do the gradient of the radius, we do need to know the point first. That's why my first step here was to find that y coordinate. So the gradient of this radius is 4 over 2, which is, I've done a lot of gradients of 2 here. I couldn't tell you like what that says about my subconscious. But if the gradient of the radius is 2, the gradient of the tangent is minus a half. All right. And we do want to find the plus c for this one. So y is minus a half x plus c. We need to make it go through the point 2, 4. So we're going to plug that in. Y is 4. X is 2. C is 5. Because what we want, in fact, we probably, we're going to cheat a little bit. There we go. So the line crosses the y-axis at the point Q. Oh no, we didn't need that one. So we want this one. So we want to find out where this line crosses the y-axis. Previously, we were figuring out where the line crosses the x-axis. In this case, we are figuring out where the line crosses the y-axis. And where it crosses the y-axis, we're going to use x is 0. But we already know that that is our y-intercept of 5. Okay? Now then, let's find the area of this triangle. Well, if we take this triangle and just draw it over here, so that's Q, that's O, and that's P. What is the length of OQ? Well, we start at 0 and we go up to 5, so the length of OQ is 5. Now, we could muck about with that right angle, but we don't need to. My height is just the distance here. That is what my height is. And what is that the equivalent of? Well, it's just the equivalent of the y-coordinate of P. This is something that comes up quite a bit and is worth being quite good on. So the area is 1/2, and we will take OQ as the base. Base times height. So the area is 5. Okay. How did I get 5 for Q? I found the plus C for the line. All right, so the line itself is y is minus 1/2 x plus 5, which means its y-intercept is plus 5. No, Chelsea, half base times height works for any triangle. It's just that you've got used to the fact that you take, in a right angle triangle, you take base and height in that way. But any triangle will work, so long as base, height, all right? Or in my case, if you do it sideways, but that works absolutely fine. Okay, let's keep pushing. We're on to circle theorems. All right, now really, you want to be able to find these equations of lines, find out where they meet. Also with a circle, radius and tangents are perpendicular. That is your bread and butter. And being what does come up a lot is finding these triangles. All right, so do have a look at that. Okay, let's do some circle theorems. Let's do some circle theorems. Here we go. We've got a cool looking circle theorem jotting about here. We want to find the angle ACO. First thing I do every single time is actually write down on this thing, where is the angle that I'm looking for? Okay, ACO. And now we can start looking. Now, are there any circle theorems that jump out at me? Let me know what circle theorem jumps out at your chat. Any that we think that we might want to be able to do. What do we got? Alternate segment theorem. All right, well, give me an angle from the alternate segment theorem. What angle can we find using the alternate segment theorem in here? Whoa. And we've also got angles and radiuses. So let's start with the alternate segment theorem. Chat is live. So let's pop that in here. Angle CAB is 65 degrees because of the alternate segment theorem. And we're also going to say that that angle there is 25 degrees, which is angle OCB is 25 degrees. Why is that? I saw a bunch of this in the chat as well. Radius and tangent are perpendicular. Right, has that helped me at all? All right, does that help me at all? No, Musab, if you just quote alternate segment theorem, the mark schemes for these questions, really, what they're looking for is for you to give the proper angles, and then they are looking for buzzwords, right? Have you mentioned the alternate segment theorem? Have you mentioned that radius and tangent are perpendicular? What do we got? Right, isosceles triangle. We do have an isosceles triangle. We do have an isosceles triangle, which is going to give me the fact that I'm up here. So that is 25 degrees. So OBC is 25 degrees because we have an isosceles triangle. It's up there. We could also simply have got the fact that that is 130 degrees as well. We were well within our rights right there. So where does that leave us? Where does that leave us, chat? Well, we're going to look at the triangle ACB. So that tells me that 65 degrees, actually. I've gone to the trouble of putting a bunch of colors in. 65 degrees plus 40 degrees plus 25 degrees plus 25 degrees plus x is equal to 180. And there we go. So what's that? 50, 90, 155 plus x. Do I get x is 25? Oh yeah, we could have done angle on a straight line as well if we really wanted to. And this is where circle theorems can go in a few different ways. But if that's 40 and that's 25, this is also 65 degrees. So we could have done angles on a straight line as well. That would also have worked absolutely fine. Yes. The key for circle theorems is just to start figuring out where the angles are. You can pop in the justifications afterwards, chill, and then figure it out from there. But if you just start looking at what circle theorems are jumping out at me, use them, and then we can put it all together at the end. I don't find it's too difficult. Yeah, Musab, we could have done angle at the center is twice the angle at the edge. We could have gone for that as well. Absolutely fine, not a problem. So in fact, that probably tells me that that 40 degrees up there is superfluous, which is cool. Okay, let's go for another circle theorem. What is going on? What is going on here? Help. What can we go? Give me a circle theorem we can use, chat. Give me a circle theorem we can use. Okay, so we do not have a cyclic quadrilateral right now, so do be careful about that. A is not on my circle, so we have to be very, very careful about that. However, we do got a bunch of radius meets tangent, so we do know that these angles here are 90 degrees. So let's jot that in. We know that angle ACO is equal to ABO is 90 degrees because the radius and tangent are perpendicular. We don't have a full triangle joining up all the edges, so we're not quite there on an alternate segment, but I would suggest finding COB. What is COB? So COB is going to be 360 minus 90 minus 90 minus 80, which is 100 degrees. Now, why is that? Because angles in a quadrilateral adds to 360 degrees. Nice and easy. Simples. Right. Actually, you know what? Having said to you, find the angle of OCD. So we're looking for this angle here. I think we can get there. We can also find this angle, OBD. What's OBD? What is OBD? All right, chat, chill. I'll do a quick go through the alternate segment theorem, but let's finish this one again. Let's finish this question because it doesn't use it. So what is angle OBD? It is 28 degrees. Why? Because the radius and tangent are perpendicular. Now, finally, we are going to point out that that angle there is 360 degrees. And we're also going to point out that angle CDB is 50 degrees because the angle at the center is double the angle at the circumference. Circumference. All right, there's a lot going on, but now we should be up and running at 360. Who let me write 360 there? Who let me do that? Naughty croissant. Right. And now we should be good because we know that x is 360, take away 50, take away 28, take away 260, which is 22 degrees, which I think is what a few people have popped in there already, right? Do we concur? Right. Trying to keep up with the chat, like, boom. Why is it not angle OBD equal to angle OCD? So OBD is equal to OCD. So OBD and OCD, just because OC and OB are radii, does not mean that these angles will be the same, right? If I move D around, I can move D around and that will change these two angles, all right? That is only the case over here. We only had that because OBC forms a isosceles triangle. Here, OC and OB do not form an isosceles triangle, at least not in that quadrilateral, so that does not work. All right, so we do not have isosceles triangles here. What else we got? How come I did 90 minus 62 for angle OBD, Kezia? Because we've got a radius and a tangent that are perpendicular. All right. And this one here is because OBDC is a quadrilateral. I said I will explain the alternate segment, but let's get this question all tidied away before I do that. Okay, so the alternate segment theorem. What we are looking at, let me quickly sketch it for us. Let's see if this thing will do it. Excellent. A little bit of impromptu sketching here. All right. The alternate segment theorem says, so we need this sort of shape. We want a triangle in a circle with a tangent. The alternate segment theorem, okay, tells me that that angle in blue is equal to this angle in blue. And it tells me that this angle in green is equal to this angle in green. So if we go back to our original question here, we've got that triangle shape and we've got our tangent. So it tells me that this angle here is equal to that angle there, much like in this sketch down there. I hope that helps. Okay? I hope that helps. Help, help, help. Est-ce que ça va? But that is what the alternate segment theorem says. Could there be a question where it asks to prove this theorem? I'm going to prove a couple of theorems coming up in the next couple of slides. The alternate segment theorem would be a rough one to get you to prove. I'm not going to prove it necessarily right now. I think Neil probably has a full set of videos on that one if you are signed up. Or you can find, I'm going to show you a couple of them. But I do not have time this evening to prove every single circle theorem, all right? The alternate segment theorem would be a really rough one to get you to prove, I won't lie. So let's look at a couple of proofs. Basically, we are going to prove that angle at the center is twice the angle at the circumference. That is what we are going to prove. Let's go. I'm going to start this proof by adding in a line. What line am I going to add in? I'm going to go from O to A. Why is that? Because triangles good, not triangles bad. We want triangles. I'm not going to use a cyclic quadrilateral here because the question says do not use any circle theorems in your proof. If you are asked in the exam to prove a circle theorem, you should not be using other circle theorems. So we are going to I'm going to label a couple of angles here. I'm going to label that angle there X. And I'm going to label the other half of it as Y. Now, why is that? Well, that angle there is also X. So we're going to say that angle OAC is equal to angle OCA is equal to X. Why is that? Because I have an isosceles triangle. And we're also going to point out that angle OAB is equal to angle A or OBA is equal to Y because we have an isosceles and I'm back. You thought I'd gone, I'm not gone. So, a boy, yes, you are right. You can, but more often than not, they will ask you not to. So best to be prepared to not use them, right? The worst thing you can do is go into this thinking, oh yeah, that's fine. I'll just use the other circle theorems. When in fact, you get hammered with a question that says, don't use the other circle theorems. So hope for the best, prepare for the worst. So we've just given some of these a name and we've figured out two isosceles triangles. We are cooking. We are then going to figure out that angle COA is equal to 180 take away 2x, because angles in a triangle have to add up. Angles in a triangle have to add up to 180. And in the same way, angle AOB is 180 minus 2y, because angles in a triangle. Now that leaves me with angle COB, which is the one I was interested in. Well, COB is equal to 360 take away 180 minus 2x take away 180 take away 2y. Why is that? Because we've got angle at a point. They form a full circle, which is 360 degrees. And now it's just time to algebra the ever-living heck out of this. Though that is 360, take away 180, minus 2x is plus 2x. Take away 180, minus 2y is plus 2y. And if we finish tidying that up, 360 minus 180 cancels out. So I'm left with 2x plus 2y. And 2x plus 2y is 2 times x plus y, which is what we wanted, because angle CAB, which we probably should have stated up here. So let's cheat a little bit. No, it's not. And that is equal to twice angle CAB, which is what we wanted. QED. And a smiley face. There we go. So we up the signs change because of the minuses in front of it, right? We're doing 360 minus and minus. So when we expand that minus, when we expand those minuses into the brackets, right, it applies to the 180 and the minus 2x. That applies to the 180 and the minus 2y. Lily, that just means it's not even A level. It means quod erat demonstratum. It means what was to be proved. That is very old school. It used to be what you'd put at the end of proofs. Don't worry about that. It's just quod erat demonstratum. It just shows that you're finished. That's all. It's the flex, right? You wanna show off. You want to do basically the proof equivalent of a mic drop. You finish it off with a QED. Simples. Mohammed, I would hope your examiner knows what QED means. Birixni, that is a very personal question. I'm going to tell you how old I am. I am old enough to know better. Right. Take a second here. You should have been sent a link in your email to drop us a review on Trustpilot. Make sure to say that Nick, i.e. Diet Neil, is awesome and it's amazing and this evening is super useful. Please do drop us a review, or if you thought there were things we could do better, do pop that in the review as well. We are always looking to improve. So you should have been sent that in your emails. Go have a look. Yeah, Chelsea, QED for a touch of flair. Absolutely. Absolutely. So Lithme, saying that they are isosceles triangles is not a circle theorem. That's just using the fact that those are two radii. That is not a circle theorem. It's just what a circle is. All right. So that one you are allowed to use because it's not really a circle theorem. It's a basic fact about triangles that AO and OC are both radii. So that's not really a circle theorem. So you're allowed to use that. What do we think? One last break before we push through. We probably are going to run over past 8:30 tonight, but there we go. What do we think? I reckon let's do another 10-15 and then we'll take another break. Let's do inverse functions. Now, this is where there's a little bit of debate. I might do this slightly differently to how your teacher does it, purely on one simple fact. Do you swap the x's and the y's at the start or at the end? That's the only difference. So to find an inverse function, the best way to do it is to write your function in terms of y and x, and I do the swip swap. I swip swap first. You might swip swap at the end. I don't really mind. Then we now need to rearrange this. So the first thing we're going to do is we are going to get rid of the fraction. If there's one thing we've learned this evening is that Nick is not a big fan of working with fractions. Better than decimals, but not as good as integers. We are then going to multiply this out. We are then going to gather all the y's on one side. I do not care which side you put them on. You can put them all on the left, put them all on the right. It does not matter. It matters not to me, puny mortals. And let's take this step by step this evening. So I'm taking away y on both sides. I'm now going to add 2x to both sides. And we can then factorize the left-hand side. Boosh. Which will give me... Now, someone put that in the chat 4 days ago and they get Haribo. What do we got? Eunice, there's no such thing as too much anime. There is only the perfect amount of anime. Milo, I've got, like, if you look at the notebook, which the link is in the description, you can tell what I've got coming up. But really, I'm trying to hit those more tricky topics that haven't come up. So we've got some inverse functions. I've got vectors coming up. I've got trigonometry coming up. I think I haven't done proof because that came up. Oh, we're going to do a couple of graph transformations, some arcs and sectors. Oh, and interpolation is the other big one. All right, so let's try and get to interpolation before we run out of steam. Let's go. Let's go. But this, right? This is probably the trickiest one, sort of, that you're going to want to do for an inverse function where you've got x's in the numerator and the denominator. It's an absolute classic. Just get this sort of one done and out, so done and sorted. Aisha, interpolation is rarer, but it is in the scheme of work. And Neil covers it, so we're going to cover it. Hey boy, am I taking my maths exam tomorrow? No, actually, I took my GCSE like a month ago. All right. Transforming graphs. We need to know what these transformations are. So we are not only going to draw them, or we're going to just describe them as well. So f of x minus 2. What is that? Can we describe that using all the good words? We can't just say right by 2, Umar. Let's get all the good words. All the good words. We want to see the word translation. And we're going to use a vector. So if it's going 2 to the right, that would be 2, 0. So we need to get the good words in, all the best words. Pretend you're in charge of one of the largest economies in the world. I have all the best words. We'll take a break once we've done these graph transformations. What about, haha. So a translation 2 to the right. So where does my turning point go to? It was at 1 minus 4. It's going to go to the right by 2. So my turning point is at 3. Why is it like... There's a few typos in here, gang. There we go. 3, 4. So it's about that. I mean, if it was 3 minus 4, it'd be at 3. 1 minus 4 would be at 3 minus 4. But let's try and make it make sense. Right. 2f of x. Give me all the good words. All the good words. Ah, Umar. Perfect. Stretch. Parallel to the y-axis. We could probably get away with saying vertically as well. Scale factor 2. Basically, what it means is all my y coordinates are doubled. So instead of being at 1, 4, it's going to be at 1. For some reason, this graph does not match the coordinates, and I'm not going to be able to do it if I've got the cognitive dissonance of where that point is based on the graph. So let's change that. The turning point is at minus 1, 4. That's what makes sense. So we moved it there and we stretched it there. There we go. I was not going to cope otherwise. Right, 3. This is reflected in the x-axis. And then translation. All right, so the reflection in the x-axis is that little bad boy. And then the plus 1 is a translation. And that will be 1 upwards, which is 0, 1. So what does that do to this point? Well, first of all, it gets reflected. So it goes to the point minus 1, minus 4. And then it shifts up 1. So it will be at minus 1, minus 3. I've just changed the graph, Aradia. I just think that negative sign swapped somehow from the x to the y-axis. So we're going to take the turning point to be at minus 1, 4, which is what it should be on the graph. Something went wrong with the typing up there. And f of minus x is a reflection in the y-axis. All right. So that means that instead of being at minus 1, 4, it will go to 1, 4. Okay. Limitless, I will admit to you, I am not as familiar for AQA as for EDEXCEL. This is where there are slight differences between exam boards. If your teacher has told you you don't need to know it for AQA, do not fret, then just go with what they've said. All right. Rocking Boy, the opposite of a stretch is still a stretch, but instead of using a scale factor of 2, you do a scale factor of a half. It's a bit like when you do enlargements, right? With an enlargement, if it's getting smaller by a scale factor of 2, you would say it's got a scale factor of a half. So it's the same sort of thing. All right. Why is it minus 3 and not 3? Because we do the reflection first for part 3. So it goes from minus 1, 4 to minus 1, minus 4, and then it goes up by 1. So it was at minus 4, it goes up by 1. All right, cool kids. Oh, minus 1, 2. Well, there we go. Minus 1, 2. Let's redo the whole thing with minus 1, 2. Thank you, chat. Let's go that for minus 1, 2. So what does that do there? That would be 1, 2. Not sure what went wrong in this one. So that will be minus 1, 4. Let's change these. Oh dear. Oh dear. Minus 1, minus 2. So that would flip down and go to minus 1. There we go. That's better. and then it'll go to 1, 2. Apologies for that. There you go. What a small typo will do. We can't afford a 10-minute break, gang. Let's go for 5. 5-minute break. Then we'll come back and we'll nail this. Let's make sure we do that. Sorry for that. There was just a slight issue here. That's why the important part here was to start by writing down what the actual transformations are. Okay, to make sure we were all fine on that one. Then it's just a case of applying them to that particular point. Ishal, do you know what? It might not be, but we've got it in our syllabus. We are covering it, so you got all your bases covered and also going into A level. So we've got it in there. That's absolutely fine. The reflections are in, the translations are all in. It is worth having a look at. Okay. We'll come back to this. We'll come back in 5 minutes. It's 7:36, so come back at 7:41. I need yet another cup of tea, I think. Let's get this energy going. And I will be back in 5. You missed so much quality content there. Just take it for granted that everything I said was both hilarious, incredibly insightful, and incredibly intellectual. You've got no ways of proving otherwise. Oh, I couldn't repeat it. It was too much quality for me to repeat it. So we are just going to crack on. All right. But all I'm going to say is you would be so much richer for having heard it, and you would have a great insight into the meaning of life. Okay. Where are we at? Arcs and sectors. Let's bosh through some arcs and sectors. Okay. Basically, arcs and sectors is just about taking fractions of circles, all right? But this hasn't come up. It's a great content, a bit of content for calculator papers with pies. So, great quote there, Lily. We're going to go through a couple of these questions. So we want now the other thing to be very careful about here is what they're asking you for. The perimeter of the shaded region includes AC. So, let's start with the arc CD. What is the arc CD? Well, let's pretend there is a whole circle behind all of this, right? If I was to take the whole circle, what would the perimeter of the whole circle be? It would be 2 pi r. The radius of that circle would be 5. We don't have a whole circle. We've got 45 degrees. So we've got 45 360ths of it. Which is 10 pi over, I want to say 8, which is 5 pi over 4. I'm going to do all of this in pies for now, and then we'll do the calculator bit at the end. We'll find the arc AB, same gist. You find the whole circle, 2 times pi. Now do be careful, the whole radius for this one is 8. And again, how much of a circle do we have? We've got 45 360ths. So that will give me 2 pi. Plug that into the calculator. So the perimeter of the whole blue thing will be CD, 5 pi over 4, plus AB, plus 2 pi, plus the two sides, 2 times 3. And this is where the calc comes out. Kushboosh. 5 pi over 4 plus 2 pi plus 6. So what do we got? 16.2 to 3 sig fig. What do we think? Yaz, do we get the formulas for area and circumference? I don't think so, but they are fairly simple to remember, right? It's just you take the either circumference or area of the whole circle, and then you find what fraction of the circle you have. Okay, and that's all we do. So you don't really need a formula for it. I'm not a huge fan of the formula sheets. All right, so 3 marks, bish, bash, bosh, boof, boof, boof. Okay, CA and DB are both 3. All right, that's CA and DB. That's what that is. All right. How much do we know how of the circle I have, Fatty? You're looking at the angle. All right, the angle you have of the sector is going to be what you have. So the 2 times 3 is CA and DB are the two side bits. All right, the 2 times 3 is this bit and that bit. That's what the 2 times 3 is. Someone's someone's name in the chat is Fatty McHattie, so I'm just using that. All right. What about we want the area of this shaded region? Now, this is perhaps a little bit more tricky. What I'm going to suggest we do is we are going to split this in two. What color should I take? Let's go for B. We are going to split this thing into two right-angled triangles, both of them with an angle of 70 degrees. Because what I want is I want the area of these right-angled triangles. Let's call that O. But if we look at this right-angled triangle, we can say that tan of 70 is opposite is AD over adjacent. All right, we've now got opposite, we've got adjacent, and we've got our hypotenuse. All right, so we've now got a right angle triangle, and we're going to figure that one out. So that tells me that AD is 8 times tan of 70, which is a number. I am in degrees. Ooh, 21.98. Okay. Let's then find the area of the right angle triangle. All right, so we can find the area of the right angle triangle. So the area of OAD is half base times height. And here, make use of the ANS function on your calculator, times 0.5 times octo. Ocho? What is in? Who does Spanish? What's 8 in Spanish? Unce. All right. It's ocho, apparently. There we go. All right. Way to make me feel inadequate and point out my limitations. Does Neil say a lot? Nah. Ici, on parle français plutôt. Right. So now, once we've got this, if I double that, we can find the area of the kite. So let's double that using the ANS button. And then what do I need to do? We need to take away the area of that sector, which is what? Well, the whole circle would be pi r squared. We don't have the whole circle. We've got 140 degrees of it. So we've got 140 360ths. So I make it 97.6 to 3 sig fig. Yeah, Afia, if you wanted to, we could have found, we could have used sine to find the perpendicular height. We could have done a number of things. So pretty much it's, you could do triangle take away sector if you wanted to, and then double that. I've done kite take away sector. So I've doubled the triangle to get the kite and then taken away the sector. Audrey, if you got 97.65, it's probably a rounding error somewhere in there. which is why it's important to use the answer button. But having said that, I came up with these numbers in an exam. I think they try and make sure that you don't get these compound rounding errors too much, but do be careful. Use the answer button as much as you can. Okay. I think I've got, let's get on to some stats. Averages from a list of data. Sorry, sniff into the microphone. Not great. What's the median from our list here? Now, there's a couple of ways to do this. We have 7 bits of data. I quite like to do simply n over 2, which is 3.5, and we round it up. You round 3.5 up to 4, so you want the 4th number. 1, 2, 3, 4. It is 7. Okay. So, Ray, n plus 1 over 2 versus n over 2. That is a matter of taste and also what you've been taught. So, personally, because this way I do pretty much the same thing for discrete data and continuous data, I always do n over 2. And I know that if it's a decimal, I round it up. If it's a whole number, I have to take that midpoint. Now, 4, 5, something, 6, 3, something. The mode is 4. The mode is 4. So what does that tell me if the mode is 4? What does that tell me one of the two numbers in automatically? Zara Broccoli, yeah. If it came out as 3.1 for whatever reason, you would round up. One of them has to be 4. One of them has to be 4 because the mode is 4. So I need 2 4s, right? The mostest is 4. So the one with the mostest is 4. So I need at least a 4. And I know the mean is 5. So that tells me that 4 plus 5 plus 4 plus 6 plus 3 plus the question mark divided by 6 has to equal to 5. So what does that tell me? That tells me what's that? 4 plus 5, 9, 19, 22 is 30 by multiplying everything by 6. So I get the question mark is 8. The last one is 8. For mode, if there isn't a repeating number, there should be. Otherwise, if there isn't a repeated number, every number is the mode. If you've got 2 numbers that are the most, then you have 2 modes. It's called bimodal. If all the numbers are different, then you'd have all the modes. So if you look at list number 1, here, the mode, you have 2 modes are 7 and 8. This would be what we call bimodal, 2 modes. All right. What do I mean by take the midpoint? Let's do one more example and then we will keep on keeping on. Let's add in a 3 in there. What if I'd added a 3 to that list of numbers? Right, so 1, 2, 3, 5, 7, 7, 8, 8. We now have an even number of numbers. And what you'll see is, in order to split this in 2, I need to go halfway between 5 and 7, which is 6. That's what I mean. All right. All right. So averages from a group frequency table. First of all, what is the median class interval? What is the median class interval? Well, how many people did we sample? How many people did we sample? We sampled 20. So the median, this is continuous data. My median, we're going to do n over 2, which is 20 over 2, which is 10. So I want the 10th person. Which group is the 10th person in? The first 3 are in the first group. The next 6 are in this group. So the 10th person will be in that group. So the median class interval is 25 to 30. Okay. Now, estimate for the mean. That doesn't mean that we guess. What does the estimate mean? What do we use? These 3 numbers, I don't know exactly what they are. These 6 numbers, I don't know exactly what they are, but they are between 20 and 25. There are 7 numbers between 25 and 30. I don't know what they are. So I'm going to say, look, between them all, they come out pretty much at the midpoint. So these are 17.5. These are 22.5. 27.5. Now, do be very careful. This is an easy place to lose marks, a really easy place. Just because these are going up 0.5, 0.5, 0.5, do check. They will throw a curveball at you sometimes on the last one. Right, all of a sudden 30 to 40, the midpoint is 35. Cookie Monster, the median class interval just means the class that has the median in it. So we don't have an exact number. We're going to say it's in that 25 to 30 group. Okay? Right, so there are 3 numbers that are roughly 17.5. There are 6 numbers that are roughly 22.5. There are 7 numbers that are roughly 27.5. And there are 4 numbers that are roughly 35. Divide that by the total number of numbers. Let's go. Right. 17.5 times 3 plus 22.5 times 6 plus 27.5 times 7 plus 35 times 4 over 20. 26. Ooh, 26. Next piece of advice. Make sure that your number makes sense. Make sure that that makes sense. So we multiplied each midpoint by the frequency and then we added them up. Okay? I make that 26. Now, what do I mean makes sense? If you look at this, all these times are between 15 and 40. They're between 50 and 40. Most of them are in that middle bit between 20 and 30. So it makes sense that my mean is about 26. If, say, I'd got a mean of 30, I would have thought I'd done something wrong because the majority of my stuff is here in the middle. So it should be around that 25 mark. If I'd got a mean of 30, I'd probably think that old fat thumbs here have clicked in and I got it wrong on the calculator. So do make sure it makes sense. In the same way, if I'd got a mean of like 10, I would have been quite worried as well. So that's what we're looking for. All right, don't forget, a little reminder here that if you are following along and you haven't subscribed yet, please subscribe so you can message in the chat, ask your questions. I'm trying to field as many of them as I can as we go through, so don't forget to do that. And please drop us a like as well. It helps massively. All right, now, what I might do is we're going to circle back round to the interpolation for the median because it's getting quite late. And interpolation isn't very often, doesn't come up all that much. So what we're going to do is we are going to circle back round to this. We're going to crack on with the rest of it. And we'll circle back round to it. All right. So interpolation is finding an even better estimate for the median. All right. That is what that means. It's like a better guess, But we're going to come back round to it. Let's try and get through the rest of the worksheet first, and we'll do this right at the end. Give me one sec. And we're back. And also, because it's not in all the exam boards, it's not relevant for everyone, so we will circle back round to it. So let's do cumulative frequency, however. And you do actually do interpolation when we do cumulative frequency. So, cumulative frequency, we are between 40 and 45. We have a cumulative frequency of 1, 18, 41, 53, and 60. It is our running total. Cumulative frequency is our running total. All right. So that means there are 18 people all the way up that have a time less than 50. 41 people have a time less than 55. 60. We're just going to do one of these real quick. So a cumulative frequency graph, the main thing is we plot at the end of my intervals, all right? Because the cumulative frequency is about everything that is less than a value. So it has to be at the end of the interval. So 45 at 1, 50 at 18, 55 at 41, 60 at 53, and 80 at 60. Okay, not my best work. We do not want a ruler. It is curved, right? Not a ruler, it is curved. Important, all right? Cookie Monster it is. Cumulative frequency is where we add. Now, find the median and the quartiles. Now, this is basically what interpolation is, because we're saying, I don't know exactly, but so the median, so we know that n is 60. So we're going to look at the quartiles. So n over 4 is, we want the 15th number. N over 2, we want the 30th number. And 3n over 4, we want the 45th number. So we're going to go find them. The 15th number is down here. So that tells me that my lower quartile is 49. Now, it's not exactly 49, but it's my best guess. And this is essentially what interpolation does, but we will come back around and do that right at the end. The median is the 30th number. Which looks like it is 53. And the third quartile, the upper quartile, is the 45th number. Now, I'm not saying that I'm pretty chuffed with how I drew this, but the fact that every single one of these things landed on a line is pretty cool. Now, to yeet to... I read a word, tried to say a different word. To preempt questions, your graph will be slightly different to mine because of how you drew your curve. Shouldn't be massively different, but it might be a little bit different. The mark scheme allows for that. It allows for a slight difference in your curve. All right, how many individuals ran a time less than 52 minutes? We can do it the other way around. We can go to 52 on the minutes and find out what the cumulative frequency is. All right, so the cumulative frequency for 52 for me is 24. So 24 people did it in less than 52. How about 47? This is going to get real congested real quick. So 47 has a cumulative frequency of 6, but we want more than 47 minutes. So if 6 people did it in less than that time, 54 people will do it above. So, Mohammed, why is it not accurate? Because you are drawing a curve, right? So it's not perfect. We're each drawing our own curve. So the examiner should be comparing your answers to your curve and allow for any errors. So my quartiles are 49, the median is 53, the upper quartile is 56. Now, how many individuals ran between 43 and 56? I'm going to run out of tidy space here, I think. So 43, let's be generous and say 43 is at 1. And 56, oh, well, 56 was 45. There we go. So we're at 1 at 40, what do we say, 43. We've got a cumulative frequency of 1. At 56, we've got a cumulative frequency of 45. How many people went in between them? That is 45. Take away 1 is 44. I do apologize. You can probably hear that the cold is taking full effect here. Hey boy, we are not like a cumulative frequency graph itself. It should be a curve. It should be a curve. Connect at the start. So for a frequency polygon, you can't. The point is I can connect my cumulative frequency at 0. Why can I connect it down here? Because I have nothing less than 40. There is no data less than 40. So I can, in fact, say that there is a 0 data less than 40 because the smallest possible value of my data is 40, so I'm allowed to. Gab, not really. No, cumulative interpolation hasn't really come up in the new spec at all. Okay. Why am I minusing? Do you mean for part D? Well, one person got less than 43. 45 people got less than 56. Well, how many got in between the two? Well, of the 45 people that got less than 56, one of them got less than 43. We want people between 43 and 56, so that is 44 people in between. No, I did n over 4 for the lower quartile, n over 2 for the median, 3n over 4 for the upper quartile. That's where all this comes from. Right. Just do a curve, guys. Just do a curve. You should not use a straight line. It should be a curve. Cookie Monster, why did I do the quartiles? Because part A asks me for the quartiles. That's why. Right. Let's do some algebraic fractions. Let's go. Now, we are not going to cross multiply here. This is where cross multiplying becomes a problem because I've got something that isn't the algebraic fraction. So this is why I was not cross multiplying earlier this evening. Instead, we are going to create a common denominator. And my common denominator is going to be x plus 1, x plus 2. I can then multiply through by the denominator, which effectively gets rid of it. Okay, so that's what we got. And then we can expand and tidy up. Expand a Rooney time. Now, it might be worth expanding these two brackets. Okay. Then we can start tidying. We are probably not going to finish on time. I'm going to try and keep it as tight as possible. I think paper one, Neil overran by like an hour and a half. All right, but this will be available for you recorded anyway. Okay, but I'm going to keep going. We're then going to tidy this up by taking away 3x and taking away 5 from both sides. And we need to solve this thing. Now, does that... I do not think this solves nicely. So we need to deal with this. So we're going to use the common denominator. I am not in school tomorrow. I'm with my ed space in London, I'm afraid. Adam. We need to solve this. Now, looking at it, I don't think it factorizes, but you know what? I'm not going to overcomplicate it. It's a calculator paper. Ain't no one there to judge me. Let's just use the quadratic formula. A is 2, B is 3, C is minus 1. Let's go. X is minus B, so minus 3. Plus or minus square root of B squared minus 4 times 2 times minus 1 over 2A. And I don't know what that's going to give me. That is minus 3 plus square root of 9 minus 4 times 2 times. Cool. So it's either minus 3 plus root 17 over 4, or minus 3 minus root 17 over 4. Yeah. Okay. Do circles. It didn't come up on paper one. Hamad, we have done some questions on circles. Isabel, I would be very hesitant to not show any working. You can use the polynomial function on your calculator, but I would still put in your full working. Because the point is, yeah, if you do plug it in wrong somehow and you've got the wrong answer, you are putting yourself at risk of not getting all the method marks. So do put it in. You don't lose anything by writing it out. All right. Sadia, it's just some calculators will solve quadratics for you. So for example, my CG50, I can go in, and I think most of the class whiz ones will as well. I can go polynomial, quadratic, and I go A is 2, B is 3, C is minus 1, and there we go. And I get my two answers. So that is an option. Yeah, if it doesn't ask it in a particular way, I'm going to leave it in exact form, and we're all fine. Right. One more time. Let's do one more of these. Oh, that's a minus. And we're going to make our common denominator. So that's going to be, we're going to need the x plus 1s in this term. I'm going to need the 2x minus 1s on this one. And I'm going to need both of them for this one. I'm going to need an x plus 1. And I'm going to need the 2x minus 1. All right. Algebraic fractions has not come up. It will come up somewhere in paper 2 and 3. So let's prepare for it for tomorrow. So this means I can now multiply through by that denominator and essentially ignore it. And then it became a game of algebra, which is a Game of Thrones rather rubbish little sibling. I would watch the absolute hell out of a TV show called Game of Algebra. But I think that says more about me. Don't forget the minus applies to both terms. I'm speeding up the algebra a little bit here for you because it is getting a little bit later in the evening. Take your time when you go back through this tomorrow morning and try all the steps yourself. So I think this quadratic becomes 6x squared minus 4x minus 22. And I'm aware we could just leave it like that, but we can also factorize it for ourselves. Now, game of cheating, yeah, sure. And I'm going to be a little bit sneaky. I'm going to use my super cool calculator polynomial function, which your class whizzes will have. Hang on, did I use two? Oh no! Oh no, how did that happen? How did that happen? Oh, that's catastrophic. Oh, we waited till the very end to tell me that. Oh no. Ah! Right. Okay, let's do some quick fixes here. So that should be a minus 4. So that should be a plus 11. That's a 3, so that should be a 9x. Okay, that's that fixed. That should be a plus 3. So that should be a plus 2x. And that should be a minus 8. Ooh, does this make for a nicer equation, though? Does that make for a nicer equation? Is that better? I think that does. I think that does. And in fact, this one, 3x, x, 4. Oh, yeah. I really need to stop getting excited about that kind of stuff. X is minus 4 over 3, or x is equal to 1. Khalid, we don't need to use the quadratic formula. It's just if we can't really see if it factorizes or not, you can do it. All right, can we stop with the cheating? Because whatever it means, I'm getting the vibe that it's not anything particularly pleasant. So can we stop that, please? Okay. Yes, Riley, if you're not entirely sure and you're not particularly confident doing the factorizing, you can absolutely just use the quadratic formula. Okay. I would work on all of them at the same time, just to make sure you don't. Otherwise, if you ignore a part of it and bring it back in, there's a much higher chance of you forgetting something. All right, so that's why I go, my first step is I'm going to create my common denominator. Bosh, 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 bosh. I leave the denominator in, so no cross multiplying. That's where it goes wrong. Bringing the 3 back in at the end, that's where it goes wrong. So we are going to leave it in and we're going to work on it all properly. No, Maddie, we wouldn't lose marks for quadratic instead of factorizing unless the question makes us factorize. All right, upper and lower bounds. This is a great one for calculators. We are getting there, boys and girls. We are getting there. So V is S over T. we want the upper bound for v. So what is the upper bound for v? So v is s over t. So if I want v to be big, I want the s to be big or small. We want s to be big. We want s big. And we want t small. Yes. So what is the biggest value of s? So it's 3.54 correct to 2 decimal places. That would be 3.545 for its upper bound. And t, as small as possible, would be 2.6715. So let's see what that does for me. 3.545 divided by 2.6715. That will be 3 decimal places, right? So 1.327, it looks like. Now for the lower bound of v, to make a fraction as small as possible, we want s to be small, and we want t to be big. So that would be 3.535 over 2.6725. And we'll make the lower one big. Yeah, that's correct. Oh, 535. There we go. Divided by 2.6725. 0.323. Okay. Now, before we go on to the next one, what do both of these bounds agree to? So this is going to take us into the next one, but what do they both agree up to? They obviously don't agree to their 4th decimal place. What if we rounded them to 2dp? What does this one round to 2dp? All right, so to 3 decimal places, the upper bound is 1.327, the lower bound is 1.323. To 2 decimal places, that one is 1.33, that is 1.32, so they don't agree. To 1 decimal place, that one is 1.3, and that one is 1.3. And this is where they agree. So what I can say for certainty, I can say that v is somewhere between 1.327 and 1.323, which means no matter what the value of v is, it will round to 1.3. Oh, not sure if my throat will get me all the way to the end of this. Right, let's do the same exercise here. So f is square root of g over h. Let's find the upper bound of f. So the upper bound, we're going to make the top as big as possible. And we'll make the bottom as small as possible. And the lower bound the other way around. Can you guys sort those out for me in the chat? Tell you what, we will do vectors after this. We'll do vectors after this question. So let's find these. So 0.384 to, I don't know, 0.38422. And turn that into a 6. 38267. All right. To 5 decimal places, they don't agree. To 4 decimal places, do they agree? To 3 decimal places, do they agree? And I might need to drop this down because we're getting... They don't. To 2 decimal places, they agree. So what I can say, what is the suitable degree of accuracy for F? I can say that F categorically will be 0.38 to 2 decimal places. Okay. Right, it's 8:30. Let's keep on going. You can, like, this is all recorded. I know it's quite late for you, but let's crack on. We'll do iterative formula afterwards, bearings and Pythagoras. There's been a big hum of questions for vectors, so let's go to the vectors questions. Let's go. Right, the classic one in vectors, show that PMQ is a straight line. So the general thing that we want, if PMQ is a straight line, really what you want to show is that PM and PQ are parallel. Or if you really wanted to, you could show that PM is parallel to MQ. That would also work. My personal preference is to go for the first one. All right, so let's find the vector PM. So what do we know? Well, we want to get from P to M. What are we told about? We're told stuff about XP and PY. We're told stuff about OM and MY. And we're told something about Q. So let's find some of these vectors. X to Y. Well, X to Y is what? Is B. Awesome. Why is that useful to me? Well, what is O to Y? O to Y is therefore A plus B, because it is O to X plus X to Y. Because that allows me to find O to M. Now, how am I going to find O to M? Well, O to M to Y is a 5 to 2 ratio. So O to M is 5/7 of OY. So that is 5/7 of A plus B. So that's pretty useful for me. I probably did want to get XP as well. X to P, what are we told? XP, that is a 1 to 2 ratio. So XP is 1/3 of XY. So that is 1/3 of B. Right. So we can now find P to M. P to M is P to X plus X to O plus O to M. So P to X is going to be minus 1/3 B. X to O is minus A. O to M we've already done O to M. That is 5/7 A plus B. And it is worth tidying this up. What's minus a third plus 5/7 of B? You can always use the calculator. 8/21. Okay. So if we can do this question, we are all sorted for vectors, right? So it's pretty big. It's pretty big. Oh, O to Y is B. Oh, thanks, gang. So the diagram is wrong. The diagram is wrong. Ah. Okay. Okay. Let's redo that. Did not read my own question. It's late for you. It's late for me. I could probably rescue some of that, but let's just go from scratch. Thank you, chat. Thank you, thank you, thank you. Right. Ugh. Right. So, let's do that again. Let's go from X to Y. So, to get from X to Y, we're going to go from X to O, and then we're going to go from O to Y. X to O is minus A, and O to Y is therefore B. So that's quite nice. And therefore, that tells me X to P is 1/3 of XY, which is minus a third A plus a third B. We are going to want O to M still. O to M is pretty solid, but that's a little bit easier. It is 5/7 of B in that case. So which means we want to get from P to M. So P to M is P to X plus X to O plus O to M. So P to X is minus XP. X to O is minus OX. And then we want to go O to M. 1/3 A minus a third B minus OX, which is minus A. And OM is 5/7 of B. And we get vaguely similar things to what I got before. Minus 2/3 A, 5/7 minus a third. Oh, we get that anyway. 8/21 of B. So that's PM. We probably want to get P to Q now. All right, we want to get from P to Q. How do we do that? How would I get from P to Q? I would go from P to Y, and then I would go Y to Q. That is probably our easiest way, because P to Y is 2/3 of XY, and YQ is minus a half of A. So what did you say XY was? So that is minus 2/3 of A plus 2/3 of B minus a half A, which is minus 2/3 minus a half. That is minus 4 minus 3. That's minus 7/6. Plus 2/3 B. So let's rewrite those up there. PM is minus 2/3 of A plus 8/21 of B. PQ is minus 7/6 of A plus 2/3 of B. And looking at this, I would say that PM is 7/4, 4/7. Is 4/7 of PQ. There we go. All right. Now, let's just go through all of that. There was a lot going on, all right, and we're pressed for time. But let's look at the strategy here. PMQ is a straight line. So this is our starting strategy. We want to show that either PM is parallel to PQ or PM is parallel to MQ. Now, to do that, that tells me these are the two vectors I want to build towards. I want to build towards vector PM, and I want to build towards vector PQ. All right, so I want to get from P to M. All right, that's not perfect, but still. So how do I get from P to M? Really, this is the key to that. How do I get from P to M? To get from P to M, I decided to go P to X, X to O, O to M. That's what I've decided to do. And then it's about finding those vectors in terms of other ones and putting them in. 4 marks is probably quite stingy for this question. I won't fib. All right. But just put down your working and get as many marks as you can get from them. All right. So that means start writing out your working. The more working you write out, the better off you will be. Explain the route that you are taking. If you're going from P to M, write down the routes with the numbers, with the letters first. I'm going from P to X, X to O, O to M. That is our clue. All right. I would say this is worth doing because you can pick up some marks just from your working without getting the whole thing. Okay. And we're going to do the same thing for PQ. Now, the aim here is once I've got these things, right, I ended up with an expression for PM. And I ended up with an expression for PQ. And the whole point is to show that they are parallel. We want PM is K lots of PQ. That's what we wanted to find. And you need to find what that K is. How do I find that K? Well, you could divide these coefficients. All right, you can divide these coefficients. So if I do minus 7/6 divided by minus 2/3, you will get that that's 4/7. And if I do 2/3 divided by 8 over, actually, I want to do it the other way around. PM over PQ. So minus 2/3 divided by minus 7/6. That will give me 4/7. And 8/21 divided by 2/3 is 4/7. And it's the fact that they both come out as 4/7 which gives me the result that I want. Yeah, Hyper, if they are parallel, they should have a common multiplier. Okay, but this pretty much sums up, I thought I had more than one vector example, but this pretty much sums that one up for us. So that is our general technique. That is our general game plan for these. All right, let's do Do they have to share point M for it to be a straight line? So they just need to share a point. All right, who asked that? They just need to share a point, which is why I've done P to M, P to Q. They share P. Or P to M, M to Q, they show M. So long as your two vectors share a point and are parallel, then they will form a straight line. So the key is to share a single point, but the trick is it doesn't have to be that middle point. And the vector M to Q, I knew was going to be harder to do than the vector P to Q. So I did one tricky vector, P to M, and one easy vector, P to Q. So you don't have to use the middle point as the one that they have in common. You can use the starting point. You can use the starting point. Yeah. So you would then say, therefore, PM and PQ are parallel and share point P. Therefore, PMQ is a straight line. Sorry, my handwriting started out this evening as a bit iffy. It is now absolutely abysmal. Right, let's do some iteration. That seems to be a popular one that people want to look at before we crash entirely. So one question, we're going to do all of numerical solutions. So first of all, how do you show that x cubed minus x squared plus 3 has a solution between -1 and -2? All we do is we plug in those two values. I make that 1. It's -8 -4 plus 3. -11, which is -8. And we have a change of sign. So my graph has gone from positive to negative. Yeah, this one should work. This one should work. I really hope it does. I had to test it quite a few times. Etienne, no worries. Oh, Mohammed, you got me doubting myself. Like, I tested this. I know I tested this. I have to have tested this because I wanted it to do a certain thing. No, let me say, you do make sure you put brackets around your minuses. Make sure you put brackets around your minuses and it should come out as +1. Okay? Right, the whole trick for the iterative formula is you start with something equal to 0 and we want to end up with something equal to x. And here is my little trick. My little trick is give yourself loads of room and then just work from the bottom back up. So x is, because there's so many ways you can rearrange these things. So start with the end. Oh, if you start from the end and work your way back up. Zep, a change in sign means there is a root in there, because if you think about it, what it means is, if this is, sorry, the pictures are getting worse and worse here. It means that at -1, my graph was positive, and at -2, it's become negative, right? So, sorry, the other way around. Right, at -1, it's positive. Right, at -1, it's +1. At -2, it's at -8. So it means that if I've gone from positive to negative, I have to have crossed the x-axis, which means there is a solution. Right, back to part 2. We start at the end and we rearrange going upwards. And there we've got it. So you rearrange backwards is what I would recommend. All right, so you start at the bottom, rearrange going up. And then what we get is the iterative formula xn plus 1. So my next guess is the cube root of the previous guess squared minus 3. So if we start with x naught is 1, my next guess would be cube root of 1 squared minus 3, which is, and this is where we can use our calculator smart like. So what we do is we put in our first guess and we press enter or equals or whatever you've got. We then put in our formula, but we are going to use the ans button. So ans squared take away 1. Take away 3 even. Oh, I do apologize. Come again. Let's not do that. What? Better. Much better. It's what happens when you get the fancy calculator. And then we can just press enter again. And we can press enter again. And quite frankly, we can press enter a whole load. Okay, but they wanted us to use it twice, so our estimate is here. That is our estimate. The question asks us to use it twice, so we will use it twice. Oh yeah, it is -9. Sorry, it is -9. Thank you for that one. As you can tell, the cold is taking hold. The brain is getting fuzzy. The hour is getting late. But this is our idea for iteration. If you can do this, you are sorted for iteration. Okay, so key things. Look for a change of sign. They love doing that to start a question. Next one, show that it can be arranged. Start from the end. All right, write it backwards. Start from the end and work your way up. And then use the ans button. And you are golden. And you can go with this. This is not in IGCSE. I know for a fact that this is not in the IGCSE. All right. What do we do if there's a constant value? I don't know what you mean, Daniel. Limitless, the change of sign, I mean, it's gone from positive to negative. That's what I mean. P. Coombs, have a good night. We could always put a cheeky QED in here. All right, but iterations, actually, if you can do these things, are fairly straightforward. So, boys and girls, this is recorded. So if you are flagging, please do feel free to log off. And you can always rewatch this tomorrow morning. I'm going to do the bearings quickly. So limitless, the positive to negative tells me, so let's just actually go through that. The positive to negative tells me that I should have a solution somewhere between -1 and -2. And lo and behold, look, we got a solution at -1.122. All right, so that's the whole point of that point, part one. Part one, because I go from positive to negative, going from -1 to -2, That is a change of sign, which means there is a solution between -1 and -2. Then by doing the iteration, I got this solution -1.122, which tells me that in fact, and that agrees with part 1, because -1.122 is in between -1 and -2. All right. I'm just going to push on here and try and get all of these done now. We're going to do some bearings. Ships A and B leave a harbour at the same time. Ship A sails, so they're leaving the same harbour. And we're doing bearings, so we're going to measure north. So 8 kilometers on a bearing of 60 degrees. That's where ship A is. And 60 degrees is clockwise from north. So we got that. Ship B, on the other hand, sails 10 kilometers on a bearing of 120. So he's gone 10 kilometers and the bearing there is 120 degrees. So that is my diagram. That is your diagram. Calculate the distance between the ships. This is just a cheeky cosine rule. The angle there is actually 60 degrees and we can just cosine it. D squared is 8 squared plus 10 squared minus 2 times 8 times 10 times cos 60, and we can go with that. Times 10 times cos 60. So I get d squared is 84. So I get d is square root of that. You're not my real mum. There we go. 9.165. Now calculate the bearing of ship B from ship A. So that gets a little bit more tricksy because we want ship B from ship A. So we have to start at ship A. When it's from ship A, we start at A, we draw north, and we want that angle there. Now the sad reality is that to do this, we need an angle, another angle in this triangle. We need another angle in this triangle. So we are going to figure out that angle here. I'm going to figure out that angle because I'm cool like that. How are we going to do that? What rule is going to let us do that? Sine rule. Yes, Pranav, sine rule. I've devolved even into not using algebra. I'm just full on using question marks. So sine of that angle over 10 is sine 60 over 9.165. And then now I want shift sine of aunts. Ah, that's unfortunate. 70.9 degrees. Okay. Ibrahim, we are doing the sine and cosine rule right now. S, I know we need the green angle, Pranav. I know it's a bearing, but to find the bearing, I need at least one more angle in this triangle, right? There's no way around it. I do not have the correct angles yet, so I need an angle. So once I've got that orange angle, we are good to go. But we do need to think about this a little bit more. So let's have a little think. So I know that this orange angle is now 70.9. All right. That is 70.9. I also know that that angle is 120 degrees. Why? Because the two blue angles here are co-interior. So finally, that tells me that my green angle, my bearing, is equal to 360 minus 120 minus 70.9. Which is 169.1. And of course, bearings should be a 3-digit bearing, so we'll go 169 degrees. Oh, this one, because it's got a cosine rule and a sine rule, I'd put this at like 5 or 6 marks. How much longer is left of the live? As long as it takes. All right, as long as it takes. Yeah, bearings should be 3-digit bearings. All right. Let's do some quick 3D Pythag. Let's do quick 3D Pythag. We want the size of angle AFC. Now, the important thing for angle AFC is to get the correct triangle. So the angle AFC is there. So we're going to operate in a few different right angle triangles here. We've got ADC, so we know that CD is 7, AD is 10. So if I take the triangle ADC out of this, ADC, we can find what AC is. And AC is in fact square root of 149. Now I'm missing, I want at least 2 sides in this red triangle. I need at least 2 sides. But I haven't used the triangle FDC yet. So if I pull that out, I know that CD is 7, and I'm told that FDC is 30 degrees. So doing that, I can know that FC is FC over 7 is tan 30. That tells me that FC is 7 root 3 over 3. Oh yeah, I've indicated FAC. We want AFC, but that's okay. Same triangle, all the same triangle. Right, we still need the same lengths. So now if we look at my red triangle, oh, I've been doing it with exact values. You can do it with a calculator. We know that the tan of AFC is square root of 149 over 7 root 3 over 3. And we can go with that. The templating is still year 5-6. That's weird, that one, actually. Not sure where that came from. We have high expectations for our year 5 and 6s. I get AFC is 71.7 degrees. So the angle is at F, yes, but it doesn't matter. If you want the angle AFC, you want the triangle AFC, right? In 3D, that's probably the best way to do it. If you want an angle that involves 3 points, draw the triangle that joins up those 3 points. All right, I'd put it in the wrong corner because it's late, I'm tired, and my brain is fuzzy. But for you, when you're fresh tomorrow afternoon doing this, if you want an angle in 3D with 3 points in it, just draw that triangle, and then you'll figure it out. Okay. Okay, let's see what your results are. I got 9, so you need to get better than a 9. Oh, is it in the morning tomorrow? Okay, fine. It's in the morning. I thought it might have been in the afternoon. It's a morning exam. Sorry, it's the A levels are in the afternoon. I'm trying to hit a few extra points here. Someone mentioned simultaneous equations. Let's do a quadratic simultaneous. Do we want to do A or B? Do you want A or B? Let's make some hard choices here. A, cool. Right, quadratic simultaneous. The game is as such. We rearrange one of them for X or Y, and we hoof it into the other one. So really, we've got our choice here. I'm going to rearrange equation 2 to get X is equal to Y plus 2. And then I need to substitute that back into number 1. And then we just do, to be fair, given some of the algebra we've done today, this is some of the easiest stuff that we're going to have to do. We tidy this up. And in this case, absolutely, I'm tidying this up. And this one I did design on purpose to do the nice thing. So we get y is minus 5 or y is 3. And now we need to sub that back into number 2 to get the values of x. So x is y plus 2. When y is minus 5, x is minus 3. When y is 3, x is 5. Okay, that is by and large how we're going to approach all of those. Now, if we try number B, number B is going to be just worse fractions. Thank you, Rhea. All right, we're going to skip B. You can do it in your own time. It's the same thing. It's the same process, just with slightly more fiddly numbers. All right. HP, you keep asking for that. Do I have an AB to the X question here anywhere at all? I don't think I do. Let's do the probability question. Oh, sorry. I didn't mute myself there, but I am flagging. Okay, let's go. So a box contains some white balls and some blue balls. There are 5 more blue balls than white balls. One ball is removed at random. Second ball is removed. Different colors. Let's go. So, white and blue. So TTV has suggested that we're going to take white is X. So there are X white balls and some blue balls. There are 5 more blue balls than white balls. Well, that means that white has X balls, blue has X plus 5. So the probability of drawing a white ball is X out of. Now, what is our total then? Our total is 2X plus 5. So there is an X out of 2X plus 5 chance of a white, an X plus 5 out of 2X plus 5 chance of a blue. Now the ball isn't replaced. So we then choose either a white or a blue, a white or a blue. Now, if the first one was white, then the odds of getting a white on the second one, there is 1 less white ball. So there are X minus 1 white balls out of 2X plus 4 balls in total. Now, if the first one was white, the second one is still, the number of blues hasn't changed. So it's still X plus 5 over 2X plus 4. So it's the same tree diagram we would do with numbers, just we have got an awful lot of algebra. So that's X over 2X plus 4, and that will be X plus 4 over 2X plus 4. So, what is the probability that the balls are different colors? Well, where could I get different colored ones? If I did white blue or blue white. So the probability of white blue is X over 2X plus 5 times X plus 5 over 2X plus 4 plus blue white, which is X plus 5 over 2X plus 5 times X over 2X plus 4. My use of brackets here is very inconsistent. I do apologize. And we know that that is equal to 52 over 105. And now we just need to solve that. Now, one thing you might realize is those two numerators are the same. All right. Now, we're going to be a little bit naughty and cross multiply. I know I've told us not to, but it's getting late in the day. I've shown you how to do this without cross multiplying a bunch of times at this point. And now we need to solve this. And these numbers are looking big. It is knocking my confidence. I won't lie to you. Right, so now it's just a game of tidying up. That's all it is. $52 times 18. 936. Apologies, guys. Apologies. Right. Now, really, cross-multiplying is just a shortcut. Cross-multiplying is not what is never what you actually do. What you're actually doing when you cross-multiply is you're saying, I don't like that denominator, so I'm going to multiply both sides by 105. And by multiplying this side by 105, you get rid of the denominator. And by multiplying this side by 105, you get, like, you do what you do. And then you would multiply by this denominator and this denominator, right? Cross multiplying is just an iffy shortcut. And you might have realized at this point tonight, I'm not a huge fan of the iffy shortcuts. So this gives me 2x squared. And I'm reduced to using my calculator for this, but that's okay. 114. Now, do I feel like this has gone wrong? Possibly. Is my confidence a bit shook here? Possibly. But let's see. Uh, 114. Oh, oh, look at that. Look at that. Feeling way better already. So, which one do we want? We want the nice positive one. All right, x is 8. So, find the probability that both balls are white. What I would probably do at this point is actually redraw my tree diagram with the actual numbers in it, because that will make me a lot happier. So white was 8 over 21, 13 over 21, and then 7 over 20. So the probability of both of them being white is 8 over 21 times 7 over 20, which is 56 over 420, which does simplify, but we're going to leave it at that. Okay. The key is setting it up with algebra and creating that algebraic fractions equation to solve. Megan, tips for slowing down is just take your, really, as you can see, I've made a few whoopsies tonight by not slowing down, so I'm not always the best for that one. But what I suggest is, if you find yourself going too fast and you tend to make silly mistakes, is that means you should finish with time to spare. So you go back and you redo them. All right, you go back and you redo them. Or, flip side, is you take the time at the end of a question. If you're worried you went too fast, check it. In my case here, I got x is 8. Well, first of all, that feels good because it's a nice whole number. But go put it back into the tree diagram like I did here and make sure that the numbers all make sense and it all tidies up nicely. All right. What I would say is if you want to check a question, don't just reread it. You can't just reread maths. And if you think you've made a mistake, don't try and fudge it. Just start it from scratch. If you want to check a question, redo it entirely and make sure you get the same answer. Okay. So we've done vectors. Venn diagrams is probably quite fine. I think we are pretty much there. All right, we are pretty much there. Okay. We've got Chelsea. Yeah, okay, we'll do Venn diagrams. So you will see symbols like this with Venn diagrams. That is the universal set. Basically, is telling you what the everything possible is. It is telling you what everything possible is. That is all that is. Okay? So that's what that means. So it means that when I draw my Venn diagram with A, B, this is probably too small. I'll have to change it in a second. Oh, do you know what? Look, I've got the option for this. Let's make it pretty. My handwriting is dead. I mean, it looks wonky, but there we go. Right, Venn diagram, done. A, B, C. Venn diagrams, we start with the middle. So what numbers are in all three sets? Are there any numbers in all three sets? I don't think so. Are there any numbers in all three sets? No, I don't think so. There are no numbers in all three sets, so that's quite nice. What numbers are in A and in B? 7 and 29. And I'm going to cross these out as I go through them. What numbers are in B and in C? 15. What numbers are in A and in C? 5 is in A and C. 1 isn't, 23 isn't. And now we're left with the rest. So what numbers are only in A? 1 and 23. What numbers only in B? 11. And what numbers only in C? 17, 19, 25, 27. Now, what the universal set tells me is what are all the possible numbers. So I need all the odd numbers less than 30. Well, let's make sure I've got them. I've got 1. Do I have 3 yet? No, so I need to put it in. Do I have 5? Yes. Do I have 7? Yes. Do I have 9? No, so I need to put it in. What's the next odd number? 11, I've got that. Do I have 13? No, let's put it in. Do I have 15? Yes. 17? Yes. 19? Yes. 21? I do not have 21. Do I have 23? Yes. 25? Yes. 27? Yes. 29? Yes. And there we go. That is our Venn diagram. And then we just need to know our set notation for this, A intersection B. So we need everything that's in A and B. Now, one way to think about this is, let's do colouring in A in yellow. Hopefully this works. I quite like this with yellow and blue. B is going to get coloured in blue. And the idea is this. The intersection, that's and, it needs to have both colours. So in our case here, because I've used yellow and blue, which numbers have been coloured in twice? 7 and 29. So how many of that is there? 2 colours got coloured in twice, so that is 2 out of a possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, but really that's as... Now union, on the other hand, a UB in our case, all right, so let's have a look at that quickly. U is any color at all. All right, so the and is both colors. U is any color at all. So what's been colored in at all in my yellow and blue? Well, 1, 23, 5, 7, 29, 11, 15. So that's 1, 2, 3, 4, 5, 6, 7. That would be 7 out of 15. Okay. I'm going to go to 9:30, and I think we can then all crash at that point. Head elf, you won't need to worry about those big set operators with a bunch of them. All right. Let's do this Venn diagram quickly. 70 my Headspace students, if they like maths, English, and chemistry, there's only one correct answer to that, but there we go. Let's go maths, let's go English, let's go chemistry. And really, I am this petty. I don't like chemistry being that big. Right. Maths, English, chem. Like I say, we start from the middle. So 5 people like all 3. That's where we want to start. 11 people like maths and English. Now, maths and English is this entire bit there. So if it's 11 people total like maths and English, that's 6 people there. 7 people like English and chemistry. Boop, 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 boop. Now, 10 people, look out for words like this, only. That is the people that only like chemistry. We got that. 41 students like maths. Ooh, I'm a bit stuck right now because I don't know. I can't fill that in yet. But I do know 26 students like chemistry. So all of the chemistry bubble needs to be 26. So far I've got 17 students in there. I need a total of 26. So I need 9 in there. Which means I'm now good to do maths. I need 41 people in maths in total. So far, I make that 20 people in maths. So I need 21. And 5 students don't like any of the subjects. Now, how do I figure out how many students only like English? Pop that in the chat for me. Yes, 70 minus all the questions in the Venn diagram. So 21, 30, 40, 50, 58. I make it 12 in English at that point. And then, how many students like at least 2 of the 3 subjects? Well, if you want at least 2 of the 3 subjects, it's all of those. 11, 20, I make that 22. All right, these are not probabilities, so do read the question carefully. There's a big difference between being asked how many people and what the probability is. Right, congruency. We will end up having done pretty much all of them before the end of this, which is pretty solid. So what do we want to show for congruency? Well, we need at least one side that's the same. All right. So A, B, C, and B, C, D are congruent. You always need one side at the minimum to show that 2 triangles are congruent. I'll do interpolation after this. So what side do they have in common? Well, I mean, BD is in common. All right, BD is in common. All right, BD is in common. Nice and straightforward. So we've got a side. We now need 2 angles. Basically, you either need one side and 2 angles, or you need 2 sides and an angle. In our case here, we can get all the angles we want. I know that angle ADB is 180 minus 72 minus 46. 118, so it's 62 degrees, and that is equal to angle DBC. Check, check. We've got an angle the same. And then we've got angle ABD is equal to angle BDC, which is 46 degrees. Check, check. All right. So what have we got? We've got angle, side, angle, right? We've got angle, which is the same as that one. A side in common. And we've got another angle the same. So we've got angle, side, angle. Therefore, ABD, BCD are, oh dear, that's terrible. Are congruent. All right, we're on to hour number 4. We've done cumulative graphs. We've done one copson, I'm afraid. Listen, we will sort this out. I appreciate your concern. We are almost there. I'm going to do one interpolation just to show what it means, but it shouldn't come up. Quite honestly, it should not come up. So I'll do it for the median. You got 50 children, so that's n is 50. And let's look at our cumulative frequency as well, because that could be quite handy. 4, 12, 26, 44, 50. So the median, n over 2, is 25. So we want the 25th person. Now, which group does the 25th person live in? The 25th person lives in this group. Okay, the 25th person lives in that 65 to 70. The key to interpolation is to just draw a number line. So on the top of the number line, we're going to put the time. And at the bottom, we'll put the cumulative frequency. So at the top, 65 to 70. And at the bottom, my cumulative frequency. So we start 65 to 70 at a cumulative frequency of 12, which is where we ended 60 to 65. And we end it with a cumulative frequency of 26. The point is my median, I want a cumulative frequency of 25. And the idea is this. The proportions on top of the number line is equal to the proportions on the bottom of the number line. So that green length is 13. That orange length is 14. On the top of the number line, that green length is n take away 65, and the orange length is 5. So now it's completely up to you, much like we had previously. We can do green and green. So it's green over orange is green over orange. And we are set to solve that. So we're going to times both sides by 5. And then I'm going to add the 65. Guys, I'm going to call it at past pretty much now. No, I doubt this comes up, gang. I doubt. Like, on a technicality, it's still hidden in the spec somewhere, but I haven't seen it in a new spec paper. It used to be coming up all the time. It doesn't anymore, but at least we've covered it once just in case. Okay? Right. I do not think... Oh, yeah, we should probably look at what that actually is. But I won't... I'll level with you, gang. I do not think my voice has any more in it. I made it, yeah, 69 point. How many marks? 3 or 4? 3 or 4. Mohammed, I don't know if you did 5 hours for GCSE, but I do not. My voice and my head does not have this in there. All right. Look, hopefully there was something in here for everyone. All right. You will be absolutely fine. Just make sure you write down your working and don't panic. Tonight, I know I've kept you until 9:30, but half an hour to clear your brains now, maybe an hour, and then go to bed. Do not stay up late. Maths requires a clear head, as evidenced by this evening. It requires you to be rested. It requires you to be able to access your skills and your knowledge. A tired brain will not maths good. Again, evidence A here. All right, I do maths all the time. I've got a whopper of a cold and I have made some mistakes this evening, right? So you need to make sure that you are well rested, you've had a good breakfast, lots of water, all right? And you will be absolutely fine. Don't think I got any of that wrong. You will be absolutely fine. We are not planning on doing AQA Further Maths GCSE at this point, I'm afraid. All right, we're not planning to do that. Okay. Last answer, Head Elf, why is it m minus 65? You are trying to find the length between the number n and the number 65. If you think about it, how do I know it's 5 between 65 and 70? I did 70 minus 65. How do I know it's 13 between 12 and 25? I did 25 minus 12. So how far is it from m to 65? M minus 65. Pallav Sharma, drop a comment, drop in the review. I think anything GCSE really is Neil's purview at the moment in terms of shorts and TikTok and YouTube videos. My domain for that is the A-level further maths. All right, I'm doing the stream this evening because we've got 3 exams going on tomorrow. But if you would like some GCSE further maths, leave that in the feedback so we know what to prep going forward. That would be super helpful. Megan, discrete and cumulative data. Well, not discrete and continuous. Once it's all grouped, it doesn't matter. Once it's in a group table, does not matter at all. All right. All right, gang. Thanks for tuning in. I am going to go curl up in a ball and rock myself to sleep. Good luck tomorrow morning. Good luck. You will do absolutely brilliantly. You've been amazing, chat. Well done staying on till the end. You are the last 391 on this chat. Absolute faithful. Good luck tomorrow, and I will see you soon. See ya.